Hello and welcome to the Mastering Flask video course by Pact Publishing. In this course, you will get an in-depth look at the Python Web Micro Framework to perform advanced web application development. This course was brought together by Jack Stouffer and Alexander Putilin, and I'm Tori Clark, the voice for this course. Jack Stouffer has been programming in Python for 5 years now, and he has been creating websites for about 7, starting with toy websites written in PHP. His co-author, Alexander Putilin, has been programming in Python for about 3 years and has been professionally programming in different languages for more than 5 years. They both have GitHub accounts, which have some open-sourced Flask code hosted on it. Some frameworks like Django use batteries included approach, whereas Flask is a micro-framework. Flask itself is very small and provides basics for developing web apps, but it is extensible. There is a strong community that provides extensions for handling other things, from DB support to caching. Now let's explore what we will be building in this course. Throughout the course, we will be creating an international movie database clone called the World Film Database. This app is rather complex. Each movie has its own page with the full cast listed. Each actor and director has their own page with links to every movie they have starred in or directed. Users can create an account which will allow them to leave comments on the pages of each actor or movie. The maintainers of the site have also created a blog to give users updates on any news involving the site, which users can also leave comments on. Overall, this web app has a lot of dynamic content based around relationships between many different entities. In this course, we will cover these topics. In the first section, we'll set up some necessary utilities and boilerplate code for the rest of the course. In the second section, we'll look at how to access the database with the necessary concepts required. The third section will cover the advanced features of Flask to display the various relationships to the end user. The fourth one will see us restructuring our app using Flask blueprints. In the fifth one, we'll make our app more secure by adding login functionality and permissions. We'll then create a RESTful API of our app in the sixth section. In the seventh one, we'll create an admin interface and enhance the functionality of our app. We'll then use the Flask extensions to speed up the working of our app in the eighth section. The ninth one will see us using Celery and understand how it is used in asynchronous programming. The 10th section will see us testing our app to make it more robust. And then finally in the 11th section, we'll deploy our app to various platforms and weigh each one in that process. Awesome, isn't it? Now, this course has some prerequisites. This course assumes you already have an intermediate knowledge of Python 3.5. I also assume that you will understand enough of Flask's API to create a single web app. SQL databases are going to be used to great effect in this course, so understanding what they are and how to write SQL is necessary. Finally, it's also assumed that you have at least some understanding of how web technologies like HTTP, HTML, CSS, and to a lesser extent, JavaScript work. So, that'll be our web stack for this course. If you are unfamiliar with any of the technologies mentioned, I suggest you first watch some of the other courses or read some of the book in Pact's library to get you up to speed before you attempt this course. To follow along in this course, you will also need to have Python and pip installed, as well as a code editor of your choice. Also, to avoid complicating the videos, I will not be using an IDE in this course. So, without further ado, let's get started on this journey. Welcome back. This will be our first section, an advanced introduction to Flask. In this section, we are going to have a brief refresher on the Flask API, and we're going to set up our project for the course. In this video titled A High-Level Reintroduction into Flask, we are going to quickly go over the basics of Flask's API to act as a refresher for those that need it. We will also create a basic application that all of the following sections will build off of. First, we will need a project folder. You can call your folder anything, but I will call it WFDB. Now open your code editor to this folder and create a file called app.py, which will hold our application object and our routes for now. The app.py file now contains the smallest amount of code necessary for a Flask app to run. As you can see, The app object is created from a Flask object, which will hold all our routes and handle the application logic. Also, the home function is turned into a Flask route through the app.route decoder. And at the bottom, we can check if the file is being called from a Python process and not just imported. If that's true, we run the server. Let's install the Flask package and test our basic app. Open your preferred command line interface and run pip3 install Flask. Then run app.py file with Python. If we go to the default Flask port 5000 on localhost, we can see Hello World message in our browser. Nice! Now, in order to speed up our development and debugging time, we are going to install our first Flask extension, Flask script, and IPython. IPython is a custom Python REPL that comes with a lot of extra features, like tab completion and better documentation printing. You can use it exactly like the normal Python REPL and nothing will change, but the extra features are there if you want to use them. Flask script is a Flask extension that allows you to define functions which can be run from the command line that run inside your app's application context. Flask's application context is basically an easy way for Flask to give extensions access to the application object to modify it without explicitly passing references around. The current request object to the Flask app and all Flask extensions are held on the application context, so if you wish to use either, which we will in the upcoming sections, we need our code to work inside of it. That's why we need Flask script. The main uses for Flask script are running the server and debugging through its shell interface, which we will see more of in the next section. So, let's go back to the terminal and close the server. Then use pip3 to install Flask script and IPython. Now we need a manage.py file that will hold our Flask script commands. We will start off with two basic commands, one to run the server and one to create a Python REPL that is working inside of our application context. From now on, we will use the command python3 manage.py run server to run the server. Next, we need to add some basic Jinja templates to our application. By default, Flask looks for templates in a folder named Templates, but this can be overridden when instantiating the Flask object. Let's create a Templates folder in our project folder with a file called base.html and another called index.html. As this is not a design-oriented course, we will use Bootstrap to handle our site's design. If you have never used Bootstrap before, it is a drop-in CSS framework that gives many features like grid system and default typography. We will need to download Bootstrap to our project. But first, we will create the HTML. Index.html will inherit from base.html, and for now, it will just contain a simple Hello World message. To have our app render out our templates, we will need the render_template function from Flask. Replace the Hello World line with this line. Next, we will need to download Bootstrap. At the time of recording this video, the latest Bootstrap version is 3.3.6. However, for this course we are going to be using version 4, which is still in alpha stage. But right now, there is no option to download compiled Bootstrap. Don't worry though, it is not difficult to compile Bootstrap from the source. However, since our focus is on Flask, let's not waste a lot of time compiling Bootstrap. I have already done that, and we're going to download compiled Bootstrap 4 from the course GitHub page at https://github.com/laweek/mastering_Flask. Hit the download zip button to get a zip file of the repo we need. Unzip the file, rename the Bootstrap folder to static, and move it to your project directory. You may recall that the static folder is where Flask looks for things like CSS files and JS files. As a side note, you can change the default name for this folder when instantiating the Flask object. Now all the links that we wrote in our HTML should resolve. So let's go to the terminal and start the server, then go to the browser. Excellent! We see that Flask is rendering our templates correctly. So in this video, we created a Flask app with one route. It renders a template that inherits from a base template and pulls files from our static folder. In the next video, we will go over a very popular Python tool, Virtualenv, and why it's important for all Python projects. In our last video, we saw the basics of Flask API. This is the second video in Section 1 titled Dependency Isolation with Virtualenv. In this video, we will cover what Virtualenv is, how to use it, and why it should be used in every Python project. To understand Virtualenv, let's imagine the following scenario. You have a Flask project with a lot of packages installed through pip. Pip will handle the downloading dependencies and upgrading the libraries for you. But what happens when we develop a second non-Flask project sometime later that will use newer versions of the same packages in the Flask app? The packages installed via pip are global, or what happens when a library that you wish to use depends on a library you installed for the first project, but it uses an older version? Also, when newer versions of packages contain breaking changes, upgrading them would require extra development work on an older project that you may not be able to afford. Thankfully, there is Virtualenv, a tool that sandboxes your Python projects. The secret to Virtualenv is tricking your computer to look for and install packages in the project directory rather than in the main Python installation directory, allowing you to keep your dependencies completely separate. Virtualenv is a Python package and can be installed using pip3. After it is installed, you can access Virtualenv through the command line. Let's run the Virtualenv initializer. This will create a new folder called wfdb-venv in our project directory that will hold our project's dependencies. In order for Virtualenv to work, we need to activate it any time we run our app. To activate Virtualenv, type the following command. Now that we are using Virtualenv, we can download our dependencies. Just use pip3 like you normally would, and Virtualenv will handle the rest. Great! That rounds out the first section of this course. So far, we have seen the Flask API and created a basic application. We also saw how Virtualenv helps in dependency isolation. In the next section, we will start connecting our application to the database. Hello everyone and welcome back to another video. In the last section, we had a brief refresher on the Flask API. We also set up our project file structure and added some boilerplate code. This is the first video of Section 2, Accessing the Database. In this section, we will introduce the Python library SQLAlchemy and Flask SQLAlchemy plugin that makes SQLAlchemy easier to use with Flask. Then we will use SQLAlchemy to create simple SQL queries and create relationships between data. And finally, we will use SQLAlchemy to create some more complex SQL queries. This first video is called Connecting to the Database. In this video specifically, we will cover what SQLAlchemy is and why you should use it in conjunction with Flask. Then we will cover setting up SQLAlchemy to connect to the database of your choosing. So, what is SQLAlchemy? SQLAlchemy is a Python library that allows programmers to create SQL queries Pythonically. To understand this, let's see an example. On the screen, you will see some typical SQL queries. Writing SQL code in Python is rather verbose and requires you to combine two different paradigms of reading information in one code base, one for Python data and one for SQL data. So, what if there was a way for Python to generate SQL code by using normal Python conventions? SQLAlchemy is our answer. The equivalent SQLAlchemy code for these SQL queries is this code. As you can see, this is completely in Python, which makes it much more readable and, in turn, much easier to maintain. But before we can use SQLAlchemy, we have to install it. Using pip, install the Flask SQLAlchemy library with this command. Flask SQLAlchemy is a library that provides a bridge between SQLAlchemy and Flask. It provides some utility functions and allows configuring SQLAlchemy through Flask's configuration system. Depending on the database of your choice, you will also have to install a second library to allow SQLAlchemy to communicate with it. Now, in the app.py file, we have to import the SQLAlchemy module and initialize it. The DB object will act as the connection to our database. We also have to pass the app object to the database object. To connect to the database, SQLAlchemy needs a configuration variable called SQLAlchemy database URI. So let's add it to our app's configuration object. The value of this configuration variable depends on your database. Now, let's import the database object into the manage.py file so we can debug with it in the future. Awesome! So we have now learned what SQLAlchemy will do for our code, and we have a connection to our database object. In the next video, we will use SQLAlchemy to create representations of our database tables with objects to give an interface to the data. This is going to be video 2 of section 2, Creating Models. In the previous video, we learned what SQLAlchemy is, and using it, we made a connection object to our database. In this video, we are going to start creating an interface to our data with SQLAlchemy's ORM. So we are going to cover what ORM is and how to use SQLAlchemy's ORM. So what is an ORM, or object relational mapping? Well, when two different systems in a computer need to communicate with each other, it's possible they will have different ways of representing and classifying data. An ORM is a technique that allows the two type systems to communicate by understanding which types in each system are equivalent. In our code, we have Python's type system and our SQL database's type system. SQLAlchemy's ORM will translate these types every time we interact with the database by having our data described by special objects called models. So now we need to create objects to represent the tables in the database. For the sake of simplicity, we are going to put these classes to app.py file. Later, when it's time to modularize our app, we'll create another file, models.py, and put these objects to models.py. So in our app.py file, let's start by creating a class called user, which will abstract a user table. Each object that abstracts a table needs to inherit from db.model. First off, if you're working off an existing database, then you may need to specify the table name parameter to tell SQLAlchemy what table you want to represent. Unless your database structure follows the default table naming conventions in Flask SQLAlchemy. If you do not have database tables set up, then after we define our objects, we will use SQLAlchemy to generate our database structure for us. Each column in the table will be represented by a class variable equal to db.column. db.column takes a parameter that tells SQL what type this column should be. The most common SQL types and their SQLAlchemy types are shown on the screen. So, with this information, we can create a user table with our user object. We are going to need an ID column, a username column, and a password column for now. Our ID column will take an optional parameter primary key to make it as this table's primary key. Username will also take an optional parameter, unique, to tell SQLAlchemy that this column should have a unique index on it. Let's also create the reaper method to make debugging easier. We won't need a init function because SQLAlchemy has a default one that will serve our purposes. Great! In this video, we learned how to access the database. In the next video, we will learn how to query our user table with our new object. In the last video, we learned what an ORM was, and using SQLAlchemy's ORM, we created representations of our database tables using Python classes. This video will be video 3 of section 2, Accessing Data. In this video, we will look at how to create the basic SQL queries with SQLAlchemy using our model objects. First, open the manage.py shell. Let's begin by writing queries to create rows to our table. To create a new row in the database, just create a new user object. Then, to set the data, you can set the value of the properties. To save any changes you have made to the database, you have to explicitly tell SQLAlchemy about them by adding your object to the session. Then, after you have added your new object, run the commit command. After we have committed our changes, our database should now have a new row in the user table. Next, we need to be able to read the data in our tables. As you saw in the last video, each model has a query object attached to it. This object holds all the methods which we will use to read data from the table. First off, we can read all of the rows in the table by running the all method. Or we can use the first method to only return the first row in our database. Also, we can use the get method to return a row if we already know that row's primary key. There are also Flask SQLAlchemy specific methods to return data. First, there is the first or 404 method that works exactly the same as the first method. But if there are no rows to return, this method will fire the Flask abort function to return a 404 to the user's browser. There is also a get or 404 method that has the same functionality as the first or 404 method, but for the get method. To start filtering our results, let's use the limit method. The limit sets the total number of rows that can be returned by passing an integer. Now, before we execute this query, there is one thing we need to understand about querying in SQLAlchemy. The query object's methods are chainable, which means that each method that filters the query just returns another query object. If we run this query now, we will not get the first 5 rows of the table, but a query object. This allows many filtering methods to be applied to a query at once. To end the chain and return to the data, use either the first method or the all method. So let's add the all method to the previous query to run it. As you can see, we have now returned the first 5 rows. The next method we can use to filter our results is the order by method. The order by method allows you to specify the order of the returned results to be different than the default ascending order of the primary key. The order by method takes a property of our user class as the parameter. If you want descending order rather than the default ascending order, add the DESC method to the passed property. So if we add the order by method to the previous query, we can get the first 5 users in an alphabetical order. Finally, we can use the filter by method to filter our results by exact values. The filter by method is used to create simple where SQL queries. If we knew the username of a user we want to query by, we would pass the username as a keyword argument to the filter by method. We can pass arguments for as many columns as we want. This query will look for any user whose username is Alex, but their password column is some password. Now, as I said before, these create rather simple where clauses. But we will look at creation of advanced queries in video 5 of this section. Let's see how to create update queries with SQLAlchemy. To update rows, we will first need a query object. This query will look for any user whose password field is empty. But instead of calling all or first, we will call the update method. The update method will operate on all of the rows returned by the query object. It takes a dictionary as its parameter, with the column names as the key and the desired new value in the row as the value tied to the key. So in this example, every user who doesn't have a password will have their password set to Mastering Flask. Because we have made changes to the database, the commit method needs to be called. The update method already added all the updated rows to be committed. Finally, we will look at how SQLAlchemy can delete rows. To delete a row, simply pass a user object that represents a row in the database to the delete method on the DB object, and then run the commit method. Awesome! So we have covered a lot of ground in this video. Using our user object, we were able to generate, insert, select, update and delete queries, all from our Python interface without ever writing a single line of SQL. In the next video, we will cover how to create relationships between data to allow for more powerful queries. In the last video, we used the model objects to create the basic SQL commands entirely in Python code. This video will be video 4 of section 2, creating and querying one-to-many relationships. In this video, we will look at how we can represent data that is incorporated between many tables in our database and how to query that data. In a typical web application, data is rarely isolated. Most tables require others to have a useful value. For example, what use would a table holding blog posts be if there was no way to know which user in that table wrote the post? There are two main relationship types we will be using in this course: one-to-many and many-to-many. The one-to-many relationship describes a relationship between two tables in the database. One table is designated as the parent and the other as the child. As the name implies, in this relationship, there is one parent and many children. Also, each child can only have one parent. This example shows that a user can have many posts, but each post can only have one user. This is how we would designate an author for each post in a database. The current slide shows how this is implemented. Each child in the database contains the primary key of the parent row. This allows for some very fast queries in the post table when we want to get all the posts for a user, because it's a very simple where query. Let's start creating some of these relationships. As you can see, I have created more models for our application. These models are built off the knowledge gained in the previous video. I have created a model for actors, a model for movies, a model for posts, a model for tags, and a model for comments. Using these models, we will start creating relationships between them to create the functionality we saw in the first section. Let's start with a one-to-many relationship between the user model and the post model. On the post object, we need to add a column called user ID that will hold the reference to the parent object, which is the user.id in this case. This column will take a second parameter, db.foreignkey, which marks this column as having a foreign key reference to another table's primary key. db.foreignkey takes a string representation of the column that this value is referencing. In this case, it is the user.id column. And now, on our user model, we need a class variable called posts that is equal to db.relationship db.relationship is a helper class that automates all the special querying that needs to be done with relationships. First, we pass a string to specify the model this relationship is connected to. Then, the backref keyword argument allows us to access the parent object from the child objects. The value of the argument is the name of the attribute on the child object. In this case, the user object will be accessible from the posts object by accessing the user attribute. Finally, we have the lazy keyword argument. This tells SQLAlchemy how to load in the child objects when a parent object is accessed. We are going to set this to dynamic, which tells SQLAlchemy to load the posts only when they are accessed. So now we can go to the shell and test this feature out. First, use the db.createAll function again to create the new tables. Let's create a new post object, and I'm going to set some of the attributes. But before we save it, grab any user and put it in a variable called user. There are several ways to set the new post object as a child of the user object. We could manually set the user ID attribute with the ID of the user variable. We could append the post object to the posts attribute of the user variable. Or we could set the user attribute on the post object to be equal to user. All these methods will produce the same result. Add those objects and then commit them. And now we can see how we can use this relationship to query our data. The posts attribute on the user variable is a special SQLAlchemy class that acts like a query object. To get all the posts that are children to this user object, type user.posts.all. Every method from the previous video works on this relationship object, allowing you to filter down the amount of child objects that are returned if there are a lot of them. The relationship object also allows you to treat it like a list in some cases. If we loop over the posts attribute, it's as if we were looping over the result of users.posts.all. Oh, I'm sorry, there was a typo. Be careful when you type in your shell. We can also access the user object in the user variable by using the user attribute on our post object. Great! We covered the two main types of relationships in database data, one-to-many. In the next video, we are going to cover many-to-many relationships. In the last video, we learned about one-to-many relationships. This video will be video 5 of section 2, creating and querying many-to-many relationships. In this video, we'll look at how we can represent data that is interconnected between many tables in our database and how to query that data. Specifically, we'll look at many-to-many relationships. Just like one-to-many relationship, the many-to-many relationship also describes a relationship between two tables in the database. But in this relationship, an arbitrary number of connections can be made between two rows in a database. In the current example, we see that many-to-many relationship can describe the relationship between tags and posts on a typical blog. Each post can have many tags, and each tag can be set on many posts. This is achieved by having a third table to hold the relationship data rather than holding the relationship on each row. The primary keys of each object are stored on each row. If we want all of the tags on the post with an ID of 1, we would perform two queries. First, we would select the rows in the post tag table that had a post ID of 1, and then take the tag IDs in the results to query the tag table. It's also possible to store some information about the nature of the relationship by adding extra rows to the intermediate table, which we will do in this video. Before we move on to the many-to-many relationship, let's add two more one-to-many relationships. Each movie will have only one director, so let's add a director ID attribute to the movie model that points to our actor.id. This will not point to a user ID because actor objects representations of people, while user objects are stores in login data. Now, on the actor model, add a directorships attribute that references the movie object. Also, let's add a relationship between post objects and comment objects. On the comment model, we need a post ID column. And on the post model, add a db.relationship to the comment model under the comments class variable. Now we can learn how to create a many-to-many relationship. First, we will need to create the extra table that we saw earlier. A new variable called tags in the app.py file will be set to a new db.table object. The table object is slightly different from the model class in that it does not provide any of the abstractions that we have been using in this section. It is just a primitive way of defining a table in a database. This is fine for our purposes because we will never directly query this table. The db.table takes column objects just like the model objects. Let's use them to set up the schema we saw earlier. All that is left is to add a db.relationship object to the post object under the tags class variable. This time, however, the secondary keyword argument will be used to tell SQLAlchemy that the relationship should be stored in our new table. Now in the manage.py shell, let's start using our new relationship. Let's first create some tag objects and save them to the database. Let's also grab a post object. Now we have a relationship that can be queried on both the tag objects and the posts. To add tags to posts, append a tags object to the tags attribute of a post. To add a post to a tag, append the post object to the posts attribute of a tag. Now save the post object to the database to save our changes. And as you can see, if we access the attributes, they act just like the posts attribute on the user object. Oops, I made a typo. Now we face a problem because we need to create a many-to-many relationship between actors and movies to describe the actors' roles in movies. But we need a way to store what role they played in the film. Thankfully, SQLAlchemy has a way of storing information in a many-to-many relationship by having the relationship go through a model rather than a table object. Let's define a new model called Movie Role. This model will have 3 columns: Actor ID, Movie ID, and Role Name. Role name is just a string to store the name of the role. But Actor ID and Movie ID are both foreign key references. Movie Role will also have a db.relationship object to the movie model under the class variable movie. And finally, on the actor model, we will add a db.relationship to Movie Role under a class variable called roles. Great! Now we can test out our new relationships. Import the new classes, and let's start by making our movie objects director. We need a new actor, for instance, and I'm going to go ahead and set some of the attributes. Now we need our movie's star, so let's create another actor instance with some of the data set. Now we need a movie for our actor to star in. Also, we can easily set the director now. We'll now create a role for the star. Let's create a new movie role instance and set the name of the role. Oh, sorry, it should be role name and not name. Be careful while creating new instances. Next, we need to save the movie under Movie Role, and then we will append Movie Role to Roles attribute of our star actor. Before we explore our data, we need to save it all to the database. Let's look at our actors' roles. We can access the data by looping over the Roles attribute. Our Movie Roles attribute are also accessible from the Cast attribute of the Movie object. Awesome! A lot was covered in this video. We covered the second main type of relationships, many-to-many. In the next video, we're going to cover some more advanced queries to really filter down our results. In our last video, we went over various ways of representing relationships between rows of data in our database and how to query them. This will be video 6 of Section 2, Advanced Queries. In this video, we will go over some of the more advanced ways to filter down the results of your queries using where clauses. Also, we will cover how to use SQL's aggregation functions in SQLAlchemy. Before we dive straight into the main content of this video, we have to understand something about Flask SQLAlchemy. In normal SQLAlchemy, queries aren't made on the model object, but are done in the db.session object like so. Flask SQLAlchemy provides the syntactic sugar to express the same query in this manner. As you can see, these two methods are equivalent. But there is one important difference. With this new syntax, we can specify exactly which rows we wish to query. In this example, I'm only returning the IDs and titles of the post objects. This might not seem useful now, but it will become vital when complex queries need to be generated. In a previous video, we used the filter by method to filter the number of rows that were returned from our queries. Filter by is a simplified version of filter method, which we will be using from now on. Unlike the filter by method, which takes keyword arguments and searches for exact values, the filter method takes equality statements as positional arguments. Let's see an example. If I wanted to search for all actors whose first name was John, I would pass a statement like this. As you can see, it's exactly like an equality you would use in an if statement. This also works for the not equal test. Greater than, less than or equal to, and greater than or equal to tests. Using the equal sign, you can also test for null values by passing none. Testing for not null can be done the same way by using not equal to. Note that while normally you would use is none and is not none, when writing conditions in filter method, you have to use equal to none and not equal to none. As you can see, these results are not quite what we want. The filter method can take an arbitrary number of these tests. Every test will be passed to the where clause with an AND logical operator. Let's create a query that returns every actor that was born after 1980 and is still alive. Now let's cover some other ways to test values in the filter method. The like method creates a like clause and is used for looking for values inside strings. Passing this string to it will look for any name that starts with a J, because the percentage sign acts as a wildcard operator. The in method is equivalent to the in_SQL method and tests if the value of the column is equal to any of the values of a list. The in method can also take a query object to create a subquery. Note that we do not call the all method and that we need to use an alternate syntax to only return the column we want. The in method can be turned into a not in method by prepending the tilde character to the front of the test. So far, whenever we passed multiple values to the filter method, it has combined them with AND operator in the resulting SQL query. If we wanted to use the OR operator, this query will search for any actor whose first name starts with J or ends with N. With these filters, almost every SQL where clause can be replicated with SQLAlchemy. So now we can get the exact rows we want. Let's move on to aggregating the rows. In SQL, you have functions like max, min, sum, and count, which operate on the returned rows from the query. To achieve this functionality in SQLAlchemy, we will use the func object. Let's see an example of returning the number of user objects before we jump into specifics. This query uses an alternate syntax for querying, so we pass in a func method call. The func object acts as a generator for representing functions in SQL queries. To understand this, let's run the last query. But instead of count function, let's use a function that does not actually exist. As you can see, in the SQL run on database, our fake function was called on the user.id column. This is because func object allows any SQLAlchemy to support any function in a database. The function passed to SQL will be the method name that was called on the func object. So, min, max, and sum functions can be used very easily. These functions can be used in conjunction with group_by method on query class. It creates a group_by clause in the resulting SQL. This example query counts the number of actors having the same first name. We can see that we have 2 Johns in our database. Now we have the tools to recreate any aggregation function in SQLAlchemy. Awesome! That brings this section to a close. Over the course of this section, we have learned how to represent any SQL query in a Pythonic way. We learned what an ORM was and how it will help us interact with the database by abstracting the details. In the next section, we will look at the more advanced functionality of Flask's template library, Jinja. Hello everyone and welcome back. In the last section, we introduced the Python library SQLAlchemy and saw how it could be used to radically simplify querying the database in our application. This is the start of Section 3, Advanced View Usage. In this section, we will be using the data from SQLAlchemy in conjunction with Jinja, Flask's templating language, to make our pages dynamic. We will also use WTForms, a new Python library, to create secure and easy to validate web forms. This is Video 1, Loops and Control Structures. In this video, we will go over the syntax for if and for statements in Jinja, and we will also cover what a macro is in Jinja and how to use it. To learn the concepts of this section, we are going to be working off of static pages that are very similar to the mock-up that was shown in Section 1. We will go through each page and make the data based on the database rather than the static HTML. I'm going to launch Python's built-in HTTP server to serve these static pages. We have the home page, which will show the latest movies in order of their release date. There is a page for each actor, which contains their personal information as well as their roles in movies. It also displays their directorships, if they have had any. Also, each movie has its own page with links to each actor who played in the movie, as well as a link to the director. And there is also a page for blog and a page for each blog post. As you can see, all these pages are simple HTML and are based off of hard-coded data. So let's start by making all the routes in our app.py file. For now, each one will just return the rendered template file. The actor, movie, and post routes will also take the ID value from the URL, which will be passed to GET query to easily create URLs to a specific object's page from our templates. We can create those queries now, as they are rather simple. Make sure to use the get underscore or underscore 404 to automatically handle missing pages. Let's also pass the objects to render underscore template function. We can begin modifying our templates with the home page. From what we learned in the last section, creating a query that returns the 5 latest movies released is easy. Then we have to pass the returned list to the render underscore template function, so our template has access to the data. The first template control structure we will learn is the for loop, which acts a lot like the Python for loop. But one of the first mistakes that a lot of people make when first looking at Jinja is thinking that Jinja works just like PHP and that it's just Python code in the templates. This is not the case. Let's see what happens when we try to call the len Python global function. We see the internal server error. That's not super verbose. Let's fix that by enabling debug mode in Flask. The best way to enable debugging when using Flask script is to set debug to none in config, so when we run our code in dev environment, it is being run in debug mode, but when we run our code in production environment, the debug mode will be turned off. Now you can see that the template won't render because Jinja doesn't know what the len function is. Jinja was designed to be as close to Python code as possible, but it isn't actually running Python, so you can't run any code as you want in the templates. What you can run is any method on past objects that return values, which can be converted to strings using the string Python function. Great! The for loop is started like so. Note that the for loop is constructed with braces and percentage signs, rather than double braces, as is the case with variable substitution. Just like Python, the for loop works on iterators rather than C-style numeric loops. There is also a closing tag we have to add to end the loop. So what our loop is doing is looping over our list of latest movies and giving the body of the loop access to each movie model through the movie variable. Now we can replace our placeholder code with this loop. Copy the repeated code and put it in the body of the loop. And then replace the text with the variable substitution syntax that we have seen before. You can see us using URL underscore for function. URL underscore for is a very convenient function for generating URLs. We are passing our view function name and its parameters. We're also using truncate filter to show only the first 700 characters. Notice movie.summary here. Our model definition is missing it. Let's add it. Please note that for the model to work, you may need to add the column to your database schema, or simply create a new database and call db.create_all like we did in the previous section. I have prepared my database in advance, and I've entered in my own fake movie data in my database to demo the site's UI. Now, if you load the home page, you should see 5 movies ordered by release date. Data about the current for loop can be accessed through the loop variable. There is a bunch of helpful variables, out of which we need the loop.index, which is the current iteration for the loop, 1-indexed. If in our template we add the following variable substitution with loop.index to each movie title, the page will render with the movie's position in the list next to the title. We also have access to the first and last attributes, which return true if the current element is the first or last item in the iterable, respectively. And finally, there is the length attribute, which returns the length of the iterable being looped over. So we can use the same logic we used for the home page to add functionality to the blog page, add a query to get the blog posts, and then in the blog.html page, let's create a for loop to add all the posts on the page with links to the post page. We also add title, formatted publish date, and truncated post text. And we can do a similar thing for the individual posts pages by looping over any comments attached to the posts and displaying them. Great! We also display information about post, and we display tags with a simple for loop. Now let's turn to the actor page to learn the next control structure in Jinja. We can easily replace the hard-coded data with variable substitutes and replace our roles and directorships tables with for loops. So let's do that now. Okay, our new actor page looks good, but we don't want to show the death date section if the person isn't dead. So let's go back to the template and fix this with an if statement. Add this code where we define the death date section. As you can see, other than the ending tag, it is just like a Python if statement. Now, if the actor's death day field is empty, the death date section will no longer show up. We can also define else if statements to go along with the original if statement, like so. But that isn't necessary right now, so I'm going to go ahead and delete this. Finally, let's quickly add the code to movie.html. It is very similar to other templates. Here we have a block with information about a movie with a bunch of variable substitutions. Again, we use the URL_for to generate URLs dynamically. And here we have the for loop that generates a table with information about actors. Now let's update the nav bar by adding a link to the blog and test our code. The code doesn't quite work. The reason is that last section we added comment model with name field for username. We actually want not just username, but actual user_ID to link two tables together. Let's quickly fix this. So, note that you may need to recreate your tables using db.create_all. Or you could simply get my pre-populated database from the course GitHub page. Great! Now let's cover the feature that makes Jinja one of the most powerful templating engines, macros. Macros are like a function in Python, but instead of returning a value, a macro replaces the macro call with the template text inside of the macro. This allows template declarations, or HTML, that is commonly repeated to be only set in one location. We have formatted dates using strftime function in several places. Let's put it in macros. Just like in other parts of templates, in macros you can use HTML code, for loops, if conditions, and variable substitutions. Our macro is going to be simple and contain only variable substitution. To make the macro available to all of the pages in our project, let's take this code into the base.html file to create our macro. We will store this code inside a macro block and call this macro input. This macro will be called with a datatime object. Perfect. Let's replace uses of strftime with our macro. And now on our blog pages, you can see that our macro's HTML is injected into the page where we called it. Awesome! In this video, we successfully turned static HTML pages into a dynamic website using Jinja with SQLAlchemy. In the next video, we will learn how to create and validate web forms in our Python code using a new Flask extension. In the last video of this section, we covered how to use Flask's templating library, Jinja, to create web pages based off of our data in the database. This is video 2 of section 3, creating and validating forms with WTForms, and we will be covering the Flask extension, Flask WTF. We'll look at how forms are defined in Python and validating those forms. Flask WTF is an extension for Flask that ties the popular Python library WTForms into Flask's application context. WTForms is a library for defining and parsing forms and form data. Flask WTF also protects your forms from security vulnerabilities like cross-site request forgery. To use it, we first need to download Flask WTForms in the terminal using pip. Here is how Flask WTF works. Much like SQLAlchemy, we first define a Python object, which represents the web form in the HTML and the data that it accepts. Each form object will have fields as class variables, which represent each input tag on the form in the HTML, and have types assigned to them for easy type checking. Each field will also have validator functions on them, which will take the value passed to the form and make sure it conforms to the constraints you wish to have on the value. You can also override the validation process completely by overriding validate method in your form class, which we will do in section 5, but not in this section. When the HTML form made from the form object instance sends data back to the view, the default or your custom validate function on the class will take the data and see if it passes all type checks and validators. Before we do anything with WTForms, however, we need a secret key for our app. A secret key is used by Flask to cryptographically sign our user session data, meaning it's used to check if it has been tampered with. It's also used by Flask WTF to protect against various security vulnerabilities. At the top of the file, add this line, and for the value, it should be a completely random string of characters to ensure that it cannot be cracked. Do not share this secret key with anyone, as it will give them complete access to your site. Now we will begin to implement our comment submission on blog posts with Flask WTF. So import the needed libraries at the top of the app.py file, and then let's define a comment form object. We are going to need a field class variable for our text field, and I'm going to pass in some validators into the validators keyword argument. Let's go over what this does. The current slide shows the most commonly used field types in WTForms, but there are many more, so I encourage you to check the WTForms documentation. Each field type is rather simple. The fields whose names mirror the names of Python types try to coerce the sent data back to those types, and the select field represents a select input in HTML and takes a list of tuples to represent the choices and their values. Our text area field in the comment form will render out a text area in HTML and convert the received value back to a string. Now, these are the most common validator functions. These are also rather simple. Each of these functions also take an optional message keyword argument, which will be displayed to the user if the validator test fails. This is set by WTForms by default, and it isn't necessary to customize it. Okay, great. Back to our code now. With our new understanding of the fields and validators, we know that our comment form object has a text area that is required and has a max length of 2,000 characters. So the next step is to initialize this object in our post view. Let's do that now. Also, don't forget to enable the post method for the view to allow our form to submit to the page. To detect if the form was submitted to the page, we will use the validateOnSubmit function in an if statement. Let's also add a comment section under the if condition. The code populates a freshly created comment object with data from the form. Okay, because we don't have a login system yet, we can't set the user who posted this comment automatically, so we will add it manually for now with the hard-coded ID. And finally, add the form variable to be sent to the template. Now we need to modify our Jinja template to display the form object. In the post.html file, replace our previous form with the following. What this code does is use the text attribute on our form object to render out the various pieces of the HTML we need. We also use a for loop to print out the messages returned by the validator functions if there are any. Also, at the beginning of the form, we tell WTForms to add a hidden input tag which contains a cryptographically signed field. This field confirms that the user submitting data to the form is sending the data from our site. And now, if we load our posts page, our new form will render. Let's test it out. I'm going to submit a Hello World message and see if it appears. Oops! Apparently, we missed an import in app.py. Let's import date time and try again. I'm launching it. As you can see, after the page reloaded, our new comment has appeared. Great! At this point, we have a fully functioning app. Yes, there is no other way to enter movie data, actor data, or blog posts but from the command line. But it is entirely possible for someone to stop here and use this as an app. However, this course is just getting started. So that wraps up Section 3. In this section, we covered some of the more advanced functionality of the Jinja templating language to make our pages display data loaded from our database. We also looked at WTForms to have data sent back to the database from our rendered Jinja templates. In the next section, we will use a feature of Flask called Blueprints to clean up our code and isolate common components. See you next time! Welcome back! This is Section 4, Restructuring an App with Blueprints. Last section, we covered the more advanced features of Jinja, the templating library for Flask. Using these features, we created the first full prototype of our web app. This section will cover what a blueprint is in Flask and how it can be used to simplify our code. Then we will adopt a new folder structure for our application that will aid us in maintaining the code base. This video is the first video of Section 4, titled Creating Flask Blueprints. In this video, we will cover what a blueprint is and how to use them in our project. So, what is a blueprint? You can think of Blueprint as a mini application object. While they do not have all the functionality of an actual application object, blueprints allow you to register routes to them, which gives you the ability to share common attributes between them, like a separate template folder, a separate static folder, or a common URL prefix. Now, blueprints are named blueprints because they can be registered to an application object many times by giving the blueprint different parameters to make sure the URLs don't collide. This is not a functionality that we will use in this course, but its implementation will be clear when we cover application factories in the next video. So, let's create the blueprints that our application will use for the rest of the series. Our blog and post routes logically go together, so it would make sense to group them into a blueprint to separate them from the rest of the routes. The rest of the routes will be grouped into the main blueprint. The blueprints will define folders to hold the templates of the routes, that is a subfolder to the main templates folder. Also, all of the routes under the blog blueprint will have the /blog prefix attached to the defined URL. To attach routes to the blueprint, simply replace the app in @app.route with the new blueprint object. Since we specified URL prefix for blog blueprint, we also need to remove /blog from the route decoder. Now that the blog routes and main routes are registered on the blueprint, we have to change all the URL_for calls we made to these routes in the templates. This is because the routes are not in the global application scope anymore, and we must specify that the route we want is under a blueprint. This is done by simply prepending the name of the blueprint to the wanted route with a period. Let's go ahead and change all the calls to the URL_for function in our templates. The last change we have to make to the code is to register the blueprints down at the bottom of the code and import blueprints from Flask. Okay, everything is set up for the blueprints. Great. Let's test it out. As you can see, nothing has changed. And we see an error. This is because we specified incorrect blueprint in the URL_for function. Let's change it, and let's test it out again. Great! Now we've fixed our mistake, and everything seems to work just as expected. Awesome! So what did we cover in this video? We learned what a blueprint is and how it can apply attributes to many different routes. We also saw how to create these routes in our code and how to add them to the app object. In the next video, we will use the blueprints we have created to clean up our code and make it more maintainable. This is going to be video 2 of section 4, restructuring our files. In the previous video, we covered what Flask Blueprint is and how to use it to share common attributes between similar routes. In this video, we will use the Flask blueprints we created in the previous video to modularize our code and clean it up by separating it into separate folders and files. This will make it easier to add new features going forward and to maintain our code in the future. We will also add a configuration system which will allow our app to easily transition between different environments, as well as make the unit testing easier later in the course. Our application has gone from a very simple example to an extendable foundation on which powerful features can easily be built. However, having our application entirely reside in one file needlessly clutters our code. To make the application code clearer and more comprehensible, we will transform all of the code into a Python package and split the code into multiple files. The current slide shows the current format of our code, and this is what our code will look like after we are done. What this format allows is having the application object in a central location in the declaration of a package. It also allows the Flask extensions to be initialized and configured outside of the file in which the application object is initialized, separating the concerns of each file in the project. The file name _init_.py looks odd, but it has a specific function. In Python, a folder can be marked as a package by placing a file called _init_.py inside of it. This allows programs to import objects and variables from the Python files in the folder. This special file can be empty or can contain code, which will be run every time a file is imported from the package. The first change is to create a folder in your application directory that will hold the module. In this example, it will be called WFDB, but can be called anything except for blog or main because controllers have those names. For example, if there are two blog objects to import from, Python will not import objects correctly from the parent directory while importing inside the blog.py file. Next, move the static and template folders into a new directory along with the app.py file. We need a directory to hold the views, and let's create a main.py file and a blog.py file inside of it, as well as a _init_.py file, which we will keep empty. We will also need to create the files forms.py, models.py, and config.py in the project folder. Also, the app.py file will need to be renamed _init_.py. Now we need to start moving the code from our _init_.py file to the other files. First, cut all the SQLAlchemy code along with the imports and move it into the models.py file. And because we don't have the application object available, we need to delete the app parameter that is passed to the SQLAlchemy object. We will register our application object with SQLAlchemy in the _init_.py file to avoid circular imports. Secondly, do the same for our form objects by placing them into the forms.py file. Thirdly, cut all of the main _blueprint object code along with all the routes attached to it. And place it into the main.py file under the controllers folder. Also, the templates folder path on the blueprint declaration is relative, so prepend the following to fix the import. And now, we can do the same process for the blog_blueprint object. Next, take the configuration declarations from _init_.py and move them to config.py. In order to create the configuration system we described at the start of this video, we need to encapsulate our configuration variables inside of objects. Flask has a method to read configuration variables from an object rather than from a directory. This will allow us to create polymorphic configurations, meaning we can have a base configuration with other configurations deriving from it, like a development configuration and a production configuration. To do this, remove the code that accesses the dictionary and just assign values to variables with the names of the old dictionary keys. Now move the debug and SQLAlchemy URI declarations to a dev_config object, which will inherit from the base config object. And let's also create a production configuration object, which we will use much later in the course. The last change to the application code is in the _init_.py file As we mentioned before, we also have to initialize the database object in our app. To do this, we will use the init_app method of the database object in the _init_.py file. Finally, we have to change the imports of the manage.py file, which is a quick fix. Let's move the SQLite database file to WFDB folder. Okay, so our code is now back to a state where it can be run again. So if we go to our web browser and test out the code, we can see that absolutely nothing visually has changed. Awesome! This is going to be a common theme for this section. While nothing has changed visually, our code has already gotten into a much more understandable and clean state. But we can take this a step further. Currently, our configuration object is passed as a string in the _init_.py file. If we instead changed our code so that our application object was created inside a factory method, we could pass a configuration object into the method, creating a customized application object. For those of you who are unaware of some of the more advanced concepts in object-oriented programming, factory method is any function that creates an object. This is rather simple to implement. Just indent all the current code, replace the string in the configuration method with a variable name, and add the variable name to the function definition. What this allows us to do is easily switch between configuration objects. For example, when we switch from production to development environments, we can easily change the configuration object that is passed and change the behavior of our app. Also, we need to change manage.py file again in order to run our app. As you can see, the code for creating an application object with our new factory method is as simple as it gets. And if we check the browser again, we can see that our app is the same as it was before, visually speaking. Great, isn't it? So, what have we accomplished in this section? We have made our application structure much more modular and, as a result, maintainable. And in future videos, we will make them testable as well. We have also made it much easier to move our applications to new environments by creating a new configuration system with the application factory method. Going forward, adding new features through new Flask extensions will be made much easier through the new project format. In the next section, we will look at one such extension, Flask Login, to add a login system to our app. Hello everyone and welcome back. In our last section, we saw how to modularize our app with blueprints. This is section 5, Securing the App. In this section, we will cover how to add security measures to your app, like secure logins and registration systems. Also, we will create a permissions-based system to be used with the login system to better define what a user can and cannot do. This is video 1 of section 5. In this video, we will be using the Flask extension Flask Login in order to handle most of the login functionality. So, Flask Login is a Flask extension that is designed to make the login and authentication process a breeze for Flask users. The first step in using a new Flask extension is always installing it. Let's do that now with pip. After pip is finished installing Flask Login, we will need to create a new file in our project directory called extensions.py. This file will hold all of the code that initializes the extension objects that we will be creating throughout the course. Now import the Flask Login main object and initialize it. Then, just like the DB object, the Login Manager object needs to be registered on the app with the init app method in _init_.py. Flask Login works by storing the ID of the logged-in user in a secure cookie on the user's browser. The cookie is created when the user successfully logs in and is destroyed when the user logs out. The browser sends this cookie with every HTTP request, and if the route is marked as requiring a login, the Flask Login will check if the ID is associated with a valid user. In order for this system to work, we need to give Flask Login a couple of things. First, in our extensions.py file, we need a method that allows Flask Login to check if an ID corresponds to a valid user object. This function will take the ID as its only parameter, and if there is a valid user object, return it. If there isn't a valid user object, the function should return none. Thankfully, the get method of the user.query class does this exact thing. All that's left is to decorate the function with Flask Login's decorator at login_manager.user_loader. Also, we need to tell Flask Login where our login page is so that it can redirect unauthorized users to it successfully. To do this, just set the login_manager.login_view variable to main.login, as we will be creating the login route on the main blueprint. Next, Flask Login needs our user model to inherit another class and to implement two new methods. In the user class, inherit the user mixin class and the anonymous user mixin class from the Flask login so that Flask login knows that the user model should act as a representation of a user. Those of you who have come from a language like Java would know the user mixin as fulfilling the role of an interface. Now we need to add the two methods we mentioned earlier. First is the get_ID method. This method just returns the primary key of the user's row on the database. Secondly, we have the is_active method. The is_active method is for having a distinction in your app between users who have registered and users who actually use the site. For example, if you are able to ban users, or if users have to confirm their email, you would use this method to stop users from logging in while storing their data. We want to be able to ban users, so let's create a new column on the model called active, which will be a Boolean function, and the function will return this value. Now our user model is ready to be accepted by Flask login. And that's it for this video. We introduced Flask login and created the functions and methods it needed to tie into our user system. Awesome! We still need to find a way to handle encrypted passwords, however. We're going to cover this in the next video. In the previous video, we installed and configured Flask login. In this video, we're going to cover how to handle encrypted passwords. As you may remember from the previous section, our user model is ready to be accepted by Flask login, but we need a method to check if the string matches an encrypted password, and a method to set the encrypted password from a string. But first, for those who don't know, let's go over what password hashing is. A hashing function is a function that allows data of an arbitrary size to be consistently reduced to the same data of a fixed size. What this means is that if you take any binary data, you can pass that data into a hashing function. If any of the data does not change, you will always get the same answer, which is usually a string. It's also important to note that it's impossible to retrieve the original information from the result of a hashing function, which is called a hash. Why is this useful? Say we have a large file that contains sensitive information, and you want to make sure that it hasn't been tampered with when you get it on your computer. What the originator of the file can do is send the large file through one of the available hashing functions and send you the result. Now, when you get the file on your computer, you can send the file through the same function, and if both hashes are the same, you know for a fact that the original file and your copy are the same. You will see this very often in open source projects, especially ones that require you to install the admin access. People want to make sure that what they are giving access to their computer is the exact same software that everyone else is using. From this example, you can think of a hash as a signature of the original data. This signature aspect of hashes is why we will be using them to store our passwords. What hashes allow us to do is never store the user's password, but gives us a way of easily determining if a string is the original data for a hash. After we add password hashing, if a malicious user contains the data in the database, all they will get are the hashes, and to log in and steal their identity, the malicious user would have to brute force the password by trying every combination of letters, numbers, and symbols until the hashing algorithm produces a match. Even if you have a weak password, this could take years if the developer chooses a hashing algorithm with the appropriate amount of strength. Thankfully, WorkZoog, the library that Flask uses to handle the WSGI side of the app, has a strong hashing algorithm built in. First, the generate password hash and check password hash functions need to be imported from the WorkZoog security module. Now the two methods are going to be very simple. The setPassword method just sets the value of self-password to the return value of generate password hash, and checkPassword just returns the value of checkPassword hash. Now, when a user registers for a new account, the password value will be sent to the setPassword method, and every time the user logs in, the value of the password field will be sent to the checkPassword method. If the user object is successfully created, then the user is sent to the login page with a message that informs him or her to log in with their new credentials. Okay, we covered a lot of ground in this video. We covered what a hash function was and how it can be used to protect our user information from people who wish to steal it. That's it for this video. In the next video, we will make our new login system accessible to our users by creating login and registration pages and making necessary changes to the back end. In the previous video, we made our App Store password securely. In this video, we're going to make our new login system accessible to users from the front end. We have the login page and the registration page. Each of these pages requires a form object, a template, and a route, so let's create those in that order. In the forms.py, add imports for the necessary fields, and let's start with creating a login form object. The login form will just have two fields, a text field for the username and a password field for the password input. The new feature we will be using for this form is the validate method, which we mentioned in the video when WTForms was first introduced. The validate method controls how WTForms determines if the data entered in a form is valid for that form. For the login form, not only do we want the validators on the field objects to be valid, but we also want to check if the data passed refers to a valid user and if the password is correct. First off, because this method is overriding the implementation of validate from the form object, we want to call the form object's validate method using super, so it properly handles all of the type and validator functions. Then, we need to query to grab a user based on the username passed. If there is no such user, return false. And if user exists, then use the check password method we created earlier to make sure the password is correct. If everything is fine, return true. Also, we should add error messages to the failures to tell the user why the login failed. Now, when data is sent to this form object, it will handle all of the checking logic, so it doesn't have to be in the route logic. The register form object will be mostly the same as the login form object, except that there is a new field confirm, which must be equal to the password field. Also, we force the username field to be less than 225 characters and the password to be more than 8. In this form's validate method, all we need to check for is if there is another user who already has the desired username. Now we have both of the form objects that will handle the data from the web forms. The next step is to create the login.html and the register.html forms in the main template folder. These pages contain nothing new. They use the same logic as the template we saw for the comments section in the WTForms video. And now we move on to the register page, which looks very similar as well. Finally, we create the route functions. In the main.py file, we will add the necessary imports, and then we'll add a login route and a registration route. In the login route, an instance of the login form object will be created, and in the validate_on_submit check, a user object will be queried, and then using the login_user function from the Flask login, that user object will be logged in. The user is sent to the home page with a message that tells him or her that they were successfully logged in. Finally, the login route renders the login.html file and sends the form object to the template. The registration route will use much of the same logic as the login route, but instead of logging the user in, a new user object is created and sent to the database. If the user object is successfully created, then the user is sent to the login page with a message that informs him or her to log in with their new credentials. Next, let's use SQLite3 shell to add an active column, since we have it in our user model, but not in the database itself. Finally, Let's add a couple of imports that we missed in _init_.py and forms.py files. We can test our login process now. Head to localhost:5000/register, and I'm going to make a new user called John Doe, and we will just give him a password of password. If we hit Submit, we are successfully taken to the login page, and if we enter the credentials we've just created, we successfully log in. Okay, we can log in, but how do we make it so a view can only be accessed by logged-in users? To illustrate this, I'm going to create a view that just returns some text. At the end of this section, this view will be removed as it's for demonstration purposes only. To keep logged-out users out of this view is really simple. Just import the login required function from Flask Login and add it to the view as a decorator. That's it. Because we are logged in our browser, we can access this page. To finish this video, there are some cosmetic and cleanup things that should be done before moving on. First, our user needs a logout view. So using the logout user function from Flask Login, let's create this function now. Next, we should add a link on the navigation bar to allow people to go to the login page if they're logged out, as well as a registration link and a logout if they're logged in. We will use the current user proxy that Flask Login gives us to achieve this. We will also use isAuthenticated method to check if the current user is logged in. The current user proxy is available in both templates and in the view. Finally, let's adjust the blog page. Let's change this line to use current user instead of user with ID of 1. Let's make sure that this view can only be used by logged-in users. In the post.html, let's wrap the comment form in an if condition so only logged-in users can see it. Let's also make our users active by default by setting self-active to true in register route. Time for final testing. So, in this video, we created the login and registration pages with form objects that log in the user, and we learned how to keep logged out users out of a view. That's it for this video. In the next video, we will cover how to add specific permissions to the login system to distinguish between more than logged in and logged out users. This is video 4 of section 5, securing the app titled Adding User Permissions. In this video, we are going to add functionality to our app that allows us to define where each user can and cannot go. Each user will have an assigned role, and each view will define whether or not certain roles are allowed to access the page. All this functionality will be handled through a new Flask extension called Flask Principal. Here's how Flask Principal works. Flask Principal is based around the idea of identity, which is handled by our login system. The identity in Flask Principal is an object that provides information about the user. Specifically, it provides what are called permission objects. Whenever a page is loaded, Flask Principal checks whether or not the identity of the current user provides the permission objects to satisfy the need objects that are needed to access the view. Permission objects and needs objects work in tandem. As we will see when we get to the code, permission objects are actually created from need objects. So what permission objects really do is they tell Flask Principal when they're tied to an identity. I provide this need. Identity objects are created whenever we tell Flask Principal that the identity has changed. In our app, this would happen whenever user logs in or logs out. So there are a couple of things we need to add to get this working. The first is to notify Flask principal whenever the user logs in or out, and build the identity for the user during that process. Secondly, create permission objects. Add permission checks to views. Also, we need to add a role model to the database. The first thing that we will do whenever we use a new Flask extension is to install it. So, head to the terminal and install Flask principal with pip. Let's start adding to the code by defining the model for our role in the database. The role model will be building off of the knowledge that we already have to create a very familiar-looking object. This model will just have a name associated with it, as well as a description field. Because the role will be in a many-to-many relationship with the user object, we need to add a secondary table, just like the secondary table for the tag for the relationship to work. And then, finally, add the db.relationship object to our user model. Before we can actually use any of the functionality that we plan to add, we need to add some rules into the database. So we can go to the shell, and just as we have done many times before, create new roles in the database using SQLAlchemy commands in the shell. We also need to add these roles to the user object that we will be using to test Flask principal. We should also add some code to our registration view in order to make sure that each user is initialized with the default role. Next, in the extensions.py file, initialize the principal object. As with Flask login, the principal object needs to be registered on the application object in the _init_.py file. Next, we can create the permission objects, which will be attached to our user's identity when they log in. Let's start by importing permission object. We will just have two different permissions in our app, one based on the admin role and one based on the default role. Normally, we would need to create our own need objects to represent the security which we want to define. Thankfully, Flask principal has already created a need object that represents roles for the users. It is called the role need object. So import it, because we are going to be using it to create our permission objects. So here is how you create the admin permission and the default permission. Flask principal also provides the user need, which allows you to easily define that a specific user can only access certain view. It will not be used in our app to protect any of the views. The next step is to create a callback on the app object that executes every time the identity changes. Those who haven't used other languages other than Python that often may not be familiar with the concept of a callback, as it is not used often in Python code. A callback is any function that is executed by another function after some process has completed. This is most commonly used as asynchronous code, because some functions can only be run after the results of another are returned. This callback will be created in the _init_py file, as it requires the app object to be initialized and does not provide an init_app method equivalent. This function will be called on identity loaded. But the name doesn't actually matter. What matters is the decorator on the function from Flask principal, which we have to pass the app object to. This designates the function as a callback for Flask principal. In this function, we have to add the permission object to the identity. The function has to accept two parameters, the first being what object initiated the change in identity. In this case, it would be the application object. And secondly, the identity object, which we will attach the permission objects to. First, set the user attribute of the identity to the current_user defined by Flask login. Next, we check if the object returned by current_user has the ID attribute, because it's possible for it not to be there if this is an anonymous user. And if it exists, define a permission for a user need on the identity via the provides_add method. And then we do the same things for the roles attribute, which we loop over the list of roles and add a role need to the identity for each. Now the identity object has all the information it needs about our user. The next piece that we have to add is the method call in our login and logout views to signal that the identity has changed. This uses the identity_change method of Flask principle, so we need to import the identity_changed object. We also need to import the identity and the anonymous identity objects. After the user has been logged in with the login user function call, use the identity_changed.send method with the first parameter as the current app object from the current_app proxy that Flask provides, and keyword arguments called identity that passes a new identity object with the user's ID passed in to initialize it. This will tell Flask principle that a new user has logged in and will execute the function that we just created in the createApp method. Now we move on to the logout view. It's the same function call, but instead of the identity object with the user ID, pass the anonymous identity object instead. Now we can add some code to one of our views to protect it from people without the right permissions. Let's go back to our fictional restricted view that we used in the last section and add the following decoration. What this does is, it says that to access this view, the identity of the current user must provide the admin_permission object. The keyword argument, HTTP_exception, tells Flask principle that, instead of an exception being thrown when the user does not have the admin_permission, the Flask abort function should be called. In this case, the 403 code is used because it signifies that the user does not have permission to access the requested resource. The required decoration also works with the user need object. We can also combine permission checks in the view itself with the can method. If we wanted only people who had both the default and the admin roles, we can use both can methods in an if statement, and if the check fails, call the abort function. We now have a fully functioning login and permission system. Let's test it. It seems like I made a small typo. Let's fix it real quick. And now let's test our app again. It works! Let's go over what we learned in this section. In this section, we created a login system using Flask Login. We learned about password hashing and implemented all of the extra functionality that Flask Login needed. We also implemented a permission system using Flask principle. To do this, we used a new role model that defined what the user can and cannot do. This gives us fine-grained control over what resources are accessible by what users. So that's the end of this section. In the next section, we will create a REST API, which will allow outside users to access our data from a machine-friendly interface. Hello everyone, and welcome back to another video in the Mastering Flask video course. In our last section, we saw how to log in our users and handle permissions. In this section, we will go over what an API is, what REST is, why REST is used to create APIs, and then we will use REST to create an API for our site's data. This is the first video in Section 6, What is REST? In this video, I am going to do a basic overview of RESTful APIs. So, what is an API? API, which stands for Application Programming Interface, is a set of methods or protocols that allow third-party applications to use or extend the functionality of an existing piece of software. For example, we have been using an API for a database this entire series to store and retrieve our stored data. In data-centric web applications, it is typical for the creators of the site to create an API that allows third parties to access the underlying data. This is a win-win because it allows third parties to easily grab the data without having to parse the data out of the HTML, and it's a win for the creators of the site because anything built off your site gives it free advertising. One prime example of this is Twitter, which had a very open API for programmers very early on, which led to many different and very popular apps being created that boosted Twitter's popularity and allowed it to be what it is today. For our application, we will create an API that allows third-party programmers to access the actor, movie, role, and post data. To do this, we will be using a type of API called REST. REST, which stands for Representational State Transfer, is not a protocol definition per se. Rather, REST is a set of constraints on APIs that are designed to force the API to adhere to best practices in both the client and server code. REST was invented after years of trial and error with other API protocols and standards, like SOAP or WSDL. These older protocols were either too complicated, too verbose, or both to really become effective. REST took off because it provided a simple way to express APIs that was immediately understandable to programmers who have worked on the web. Before we create our own REST API, we need to fully understand REST, and to understand REST, let's walk through each of the constraints that REST requires. I'm going to use the term resource quite a lot. You can think of resources as objects in OOP. We can have users, actors, movies, and so on as resources. One of the big differences is that objects in OOP may have arbitrary methods to act upon them, whereas resources have a subset of fixed methods defined for them. Okay, now we are ready to discuss the constraints. The first constraint requires that the client and the server must have a separation of concerns. The client cannot handle permanent data storage, and the server cannot handle anything with the user interface. This is in contrast to normal web communications, where the server sends the client HTML, which defines the output. In REST, the output and UI is handled by the client. This forces the creators of the server software to keep it simple for the client creators. The second constraint is that the server must be stateless. What this means is that any information that is necessary to handle requests are stored in the request itself or by the client. An example of the server being stateless is the session object in Flask. The session object does not store its information on the server, but on the client in a cookie. The cookie is sent along with every request for the server to parse and determine if the necessary data for the requested resource is stored inside of it, rather than the server storing session information for every user. This constraint is designed to radically simplify the server code, as tracking state across thousands of connections gets extremely difficult. The third constraint is that all resources provided must have a uniform interface. There are many different parts to this constraint. 1. The interface is based around resources, which are models in our case. 2. Data sent by the server is not the actual data in the server, but a representation. For example, the actual database is not sent with each request. Instead, a JSON abstraction of the data is sent. 3. The data sent by the server is enough information to allow the client to modify the data on the server. This will be shown more clearly when we start implementing the API, but essentially, we make sure to always send along an ID with the data so the third party knows what resource to modify. 4. Every resource provided by the API must be represented and accessed in the same manner. For example, one resource cannot be represented in XML and one in JSON, one over raw TCP, and one over HTTP. This constraint exists to force the server creators to keep the interface consistent for the client creators. And the final constraint is that the system must allow for layers. Load balancers, proxies, caches, and other servers and services must be allowed to act between the client and the server as long as the final result is the same, as if they were not there. This constraint is to allow the server creators to easily scale their services by adding new layers in over time. When a system adheres to all of these constraints, it is considered a RESTful system. The most common forms of RESTful systems are built off of HTTP and JSON. If you haven't used JavaScript extensively, or if you have never interacted with a web API before, you might not have heard of JSON. JSON is a data messaging format designed around the JavaScript syntax for creating objects. If you have only worked with Python, think of JSON as the Python dictionary syntax. JSON was designed to be easy for people to read and for machines to parse. Keep in mind that while the Python syntax for dictionaries and JSON syntax may look similar, they are different in some aspects. For example, you can't use single quotes for strings in JSON. Each resource is located on its own URI and is modified with different HTTP request types. Generally, it takes the following form. With the first type of request, a list of all the models in the resource are returned. The second type of request only returns the model which has a matching primary key. The third type of request creates a new model in the resource using the post form data contained in the request. The fourth type of request allows the third party to modify an existing resource with a matching primary key. Finally, the fifth type of request deletes a resource based on its primary key. With each request, we also return a HTTP status code along with the contents of the response. HTTP status codes allow programmers to know the status of the request without having to parse the message body. You have most likely encountered many of these codes already, like the 404 code, which means the requested resource is not found. The most important codes and their meanings are shown in this table. We will be using these codes a lot in this video. Okay, this video had a lot of content. First, we learned what an API is. Then we learned what REST is and what it forces the API to do and not do. Then we learned what JSON is. In the next video, we're going to use Flask RESTful to create a REST API for our app data. In the previous video, we discussed REST and APIs. In this video, we are going to create REST API using Flask RESTful. To help create our REST API, we will be using a Flask extension known as Flask RESTful, so we need to install it with pip. We could just use the standard Flask views to create our API, but Flask RESTful makes the task a lot easier. We have to initialize the Flask RESTful object in the extensions.py file, and then register the new object on our application object. We are going to store all of the logic for our API in a new folder called REST in the Controls folder. To make this folder accessible to the rest of the code, we need an empty init.py file in the folder first. We will be creating the API for the movies model first, so we need to create a movie.py file where all of the code for the movie API will be held. Let's start with a Hello World example to understand how Flask RESTful works. In the movie.py file, import the resource object and create a subclass of it called Movie API. Resources in the Flask RESTful are the representations of the REST resources we discussed earlier. In resource subclasses, behavior is controlled via methods named after the HTTP methods. For example, this GET method will be called whenever there is a GET call on the URL that the resource is tied to. In this simple example, just return a Python dictionary with the Hello World text. All of the methods we create will just return dictionaries, and Flask RESTful will automatically convert the dictionary to JSON. Now that we have a resource that is returning data, we need to define its routes. Back in the init.py file, import the Movie API object and use the addResource method to add the object to the API. We need two, one for the base URL and one for calls to a specific model. If we run the app and go to localhost 5000/API/movie, you will see the Hello World JSON response we created in Movie API. Now we need to start creating the real functionality. Back in the GET method, delete the Hello World example and make sure there is a keyword parameter to accept the movie ID from the URL. The first thing we need to do is check if the movie ID was given or not. If it was given, grab the movie object with that ID or return a 404. Flask RESTful automatically generates error messages when the abort function is called within a resource. If the movie ID wasn't given, return all of the movie objects with the all method. But we have run into a problem. How do we transform our models into dictionaries? Thankfully, Flask RESTful gives a decorator that automatically transforms objects that are returned from resource methods into dictionaries. Import the Marshall with and fields objects from Flask RESTful. The way the automatic conversion works is Flask RESTful uses a user-defined dictionary with the keys as the names of the attributes you wish to expose to the user, and the value is the type Flask RESTful should convert the value of the attribute to. To understand this, let's create the dictionary for the movie model. As you can see, we are going to be returning 5 different fields to the end user, all of which are converted to the specified types. Now we need to add the Marshall with decorator to the get method and pass in our fields dictionary. If we go back to the API response we loaded earlier, we can see all of the movie objects in the database, and if we pass an integer to the URL, that model is returned. In just a few lines of code, we created everything some third party needs to get at our movie data, but we still have a lot of functionality to add. We can very easily use this code to create a simple API for the actor model, so let's do that now. This code will show all of the actor fields, but what about the relationships? Flask RESTful has this covered as well. We can define a list of objects with fields by combining the following field types. This tells Flask RESTful that we have a list of objects. We also need to create a new dictionary called nested role fields that will define how we want the movie role objects to be displayed. Make sure you have this code in the init.py file. Now, if we point the browser to localhost 5000/API/actor, you will see all of the actors in the database with all of their roles listed. This gives enough information to the users of this API to grab all of the actor models from the actor API, making this much more powerful, as well as the following REST constraints. We have only implemented get method, so let's go back to the movie.py file, and we will start on creating new movie objects with the post method. The post method will take advantage of yet another Flask RESTful feature, the ability to parse request arguments, in this case, the ones in the post data. Flask RESTful allows you to create parser objects that read the data in one of several locations and turn them into Python-compatible types. The request parser will also return an error code if a value that was marked as required is missing, or if there was an error casting the type. In a new file called parsers.py import, for each value that you wish to grab from the submitted data, use the add argument method like so. As was stated earlier, if the requested keyword argument is set to true, then the parser will throw an error if it is missing. The help keyword argument is what will be shown to the user when there is an error, so you will want to make this as helpful as possible so the end user can then fix their request. We need 4 fields in total. 1 for the name, 1 for the release date, 1 for the summary, and 1 for the director ID. Back in the movie.py file, we can use this parser to help create our post method. The first thing to do in the post method is to check if a movie ID was passed to the URL. If it was, then return an error, because the post request type does not use the ID. If the request was formatted correctly and the movie ID was not given, then initialize the movie post parser. This will automatically grab the data from the request variables and store them in args as a dictionary. Now that we have sent the data, we can assign it to a new movie object and then save it. Finally, the method should return the 201 code to tell the user that the movie object was created successfully, as well as the ID of the new model. Note that we use the abort function from Flask RESTful, not from Flask itself, so we can provide a helpful message to the end user. And let's make sure we import movie post parser as well as actor model. To test this function, we are going to use a command line function, as creating custom post requests is only possible in browsers with plugins. The tool is called curl, and it's very simple to send a post request with it. Just pass in a separated list of key value pairs into the data flag and send it to localhost 5000/API/movie. If everything went well, then the return value will be the ID of your new movie object. The next type of request is to implement the HTTP put method. As with the post method, we need a new parser. This new parser will be exactly the same as post parser, except that nothing will be required, as this method is for updating information. To start, you can copy and paste the post method and rename it. The put method is the inverse of the post method, as the put method can only be performed if the ID is given. Also, modify the attribute assignments to only change them if the argument was given in the request. And again, we save the movie and return its ID with 201 code. Using curl again, we can update the movie we just created using the new put method and change the director. Then we can check our changes by get requesting the model. The last method to implement is the delete method. All that is needed for this method is to check if an ID was passed, query for that ID, and then delete that model. Also, let's add these methods to the Actor API. First, we add parsers that are pretty similar to the parsers we just created. Then we actually add those methods together with the necessary imports. And finally, we test our Actor API. Okay, it works. Great! At this point, we have a way for our users to get and modify data using our API. However, post, put, and delete methods are accessible to everyone. We want only people with admin access to modify the data. So let's add API for authentication. First, create auth.py file. The API is going to look like this. The user provides their username and password and gets a token back. With every request that requires authorization, the user sends the token back. We check if the token is valid, and if so, we grant access. How do we make our token secure and difficult to forge? Well, we're going to use the It's Dangerous library, one of the libraries that Flask depends on. What is It's Dangerous? It is a library that provides an easy way to sign data with our private key and verify it. We're going to generate a token based on our user's ID and our private key and return it to the user. The cool thing is that It's Dangerous library allows us to easily check if the token isn't tampered. The class we need is Timed.json Web Signature Serializer. We need to instantiate it and then call dumps to get a token from our dictionary containing the information about the user. So let's implement the function that checks that the user has the admin access based on the provided token. First, we convert our token back to user ID, and if there is any error, we return it to the user. Then we check that the user exists, and finally, if the admin role exists. Now let's add the call to this function to every method in our API that modifies the data. Let's register authentication API in init.py. Then let's add parsers. The parser for post method in Authentication API is straightforward. To parse token in post, put or delete methods, we're going to use a feature of Flask RESTful. Let's create the parent parser, and then every other parser is going to be based on this token parser. We do this by using the copy method. Before testing, let's also add the missing imports. OK, now let's use curl to check our API. I have set user author to have password, and I made this user to have admin role. We run curl and get an error. This is because we need to convert between bytes and string types by providing encoding. OK, it's fixed. One more time. OK, we have our token. Let's use it to make a put request. OK, it works. OK, this video had a lot of content. We used Flask RESTful to create a REST API for our movie and actor data, and then we learned how to authenticate and authorize API users. In the next section, we will use another Flask extension to create an administrator interface. This is the 7th section of the series, which is titled Creating an Admin Interface. In this section, we will be building an administrator interface for our app by introducing another Flask extension called Flask Admin. We will use Flask Admin in order to interface with the SQLAlchemy models, as well as the file system our server is running on. Video 1 of Section 7 is titled Setting Up. In this video, we will download and set up Flask Admin, as well as create a simple page on the admin interface to demonstrate how Flask Admin works. Let's start by downloading Flask Admin with pip. Now that Flask Admin is installed, it needs to be initialized and registered on the application object, like the rest of the object in the last section. First, import and create an instance of the admin object, which we will name admin in extensions.py, and then register the extension on the app in _init_.py. Now, because Flask Admin provides good defaults while being extremely extensible, we can already see the beginnings of the admin page in the web browser. Just go to localhost :5000/admin, and all you will see is an empty page with this navigation bar, which will fill up as we register pages on the admin object. The way you add content to your admin page is by creating instances of Flask Admin view objects. View objects are like blueprints, in the sense that they combine several normal Flask views and allow you to apply them to the admin object multiple times. But these view objects also handle some Flask Admin specific functionality, like how to automatically add in a link into the navigation bar that we saw earlier. Before we start working with our models, let's create and add a simple page into Flask Admin to understand how it functions. As stated before, the view objects act much like normal Flask views, so if you needed to add something like a page containing reports on your site's analytics, you would add it to the admin page through this method. The view object will be stored in a new file called admin.py in the controllers folder. First, import the base view class and the expose functions from Flask Admin. Next, we will need to create the class that will be registered on the admin object by inheriting from the base view class. Any methods that are created in this class can be made into views by adding the expose decorator to them. For example, this index method will now be accessible from the root of the subpath of /admin. So for example, if an instance of this class is registered on the admin object with the name of custom, then this view will be accessible from /admin/custom/. Also, because Flask Admin needs to add in its templates and macros, it has a custom template rendering function accessible from self-render. Any call to self-render we'll look for the file in a subdirectory of templates called admin. So create an admin folder in the templates folder with a new HTML file called custom.html inside of it. All of the Jinja templates that will be used in Flask Admin will inherit from admin/master.html, which sets up the page layout and all of the Flask Admin control elements. To insert content into the body of the page, override the content of the body block, just as we did in the base.html file. The structure of the master.html file is rather complex, so here's a listing of all the different content blocks on the page and what each of them is for. This information will allow you to easily extend the admin interface for yourself. Now we can go to the web browser and see the results of our simple view object in action. As you can see, a link was added to the navigation bar, and if we click on it, we get the content from our HTML file. That is all for this video, so let's summarize what we have done so far. We have installed Flask Admin, and we have also created a simple view object that represents a collection of the pages on the admin interface. In the next video, we will start adding interfaces to our SQLAlchemy code. This is video 2 of section 7 titled Interfacing with Models. In this video, we will create web pages in the admin page that can interface with our SQLAlchemy models. Now that we understand how Flask Admin works, we can start adding SQLAlchemy views into our interface. In the _init_.py file, we will start by importing the model view class from the Flask Admin. All that is necessary to get a very basic interface up is to pass the model and the database object session to the model view class and then add it to the Flask Admin interface. Let's start with the user model to see the results of the default configuration. Now, if we go to http://localhost:5000/admin/user/, you will see a list of all the users currently in the database. If you click on the pencil icon, it will take you to an interface where all of the attributes of the model can be changed from the web. This even includes the many-to-many and one-to-many fields, which are represented as inputs with autocompletes, which automatically add the appropriate rows in the database. But we have a problem. Currently, this view is accessible to the whole world. Let's change that. In a new class called CustomModelView in admin.py, which inherits from the model view, we will need a method called is_accessible. Then this method will tell Flask Admin whether or not the browser who is trying to access this page is authorized. Using both Flask Login and Flask Principal, we can easily figure this out. We will simply return a Boolean, which depends on if the current user is authenticated or not, and if they have the admin permission. You should also go ahead and add this to the custom view class to protect it as well. To use this, simply place the calls to model in the _init_.py file with calls to custom model view. There are several more enhancements that we can make to our Flask Admin interface. If I only use your page, there is a field, password, which we do not need to see because it is just a hash value of password and not the actual password. Also, it would be useful to be able to search for actors by their name in the admin interface. For these features can be achieved by adding class variables into the class, which renders the model information. To do this, we are going to create two new classes in admin.py, userView and actorView. The userView class will contain a class variable called column_list, which explicitly defines if switch columns are displayed or not on the list view. It takes a tuple of strings, which represent the name of the columns. In this case, I will only pass username and active. In the actorView class, we will add a class variable called column_searchable_list, which also takes strings into bullets. Adding fields into this tool will allow the contents to be searched on the web interface. Finally, we will also add a class variable called column_filters, which is also a tuple of strings. What this class variable does is it adds an interface to create filtering conditions on the list of rows, much like a where clause in a SQL query. Because they are both dates and are a good fit for a filtering interface, I'm going to add both the birth date and death dates to the list of columns with filters. Now let's add these three classes: Customer View, User View, and Actor View to add views for all of our models. In the init.py file, let's add a view call for each of these models, and let's also add the necessary inputs. Now let's see the results in the browser. On the user page, you can clearly see that the password field is no longer showing. Now onto the actor page, you can clearly see a new put field at the top that allows us to enter search terms. Also, we have a new drop-down labeled Add Filter. If we click on birthday, we can easily add a new filter, which gives us all the actors that were born after a certain date. There is one more feature that we need to add to our Actor View object: uploading pictures of the actor. This can be easily implemented because of the way Flask Admin structures its forms. All of the forms that you see in pages created by Flask Admin are made with WTForms, which allows us to easily override their functionality. In a new class variable in the Actor View class called form_extra_fields, we will create a dictionary that contains a file upload field. First, we need to import the file field from WTForms. Then in the picture key of the dictionary, add a new file field instance with the label picture. This will add a file upload field on the actor edit page, but it won't do anything else. To actually save the image and add it to the actor model, we need to override the on_model_change method. The on_model_change method is called every time after the form on the edit or creation page is submitted. The method takes three arguments: the WTForm object, the SQLAlchemy model instance, and the Boolean flag, indicating if this is the model that is being created or just edited. The first step in writing this function is to grab the path of the pictures library using the op.path module. Next, we will use the Flask request object to grab the Python file object from the post data. Then, after checking if a photo was submitted or not, we will save the photo to the file system with the secure_filename function in order to protect against injection attacks. Finally, we save the path to the photo in the string field in the model. Now all we have to do is change the actor template to point to the photo, which is a simple task. Now let's go to our modified actor editing page and add a photo to one of the actors. As you can see, there's a new field at the bottom of the page which allows us to add a file. When we add a photo and submit, and then go to the actors page, you will now see the uploaded image. So to wrap up, in this video we started by installing Flask Admin. That explores Last Cabinet's interface by adding a very simple view to it. Then we started adding interfaces to our database data through SQLAlchemy. Finally, we customized these interfaces to add more selection controls to them, as well as add more form fields. In the next video, we'll take a look at adding an interface to the file system on the server into the Flask Admin interface. This is video 3 of section 7, which is titled File Storage and Retrieval. In this video, we are going to cover how to add an interface to Flask Admin, which allows us to work with the server's file system. Adding a file system interface to the admin page is a rather simple task. The first step is to import the file admin class from the Flask Admin in the _init_.py file. Then we will use the add_view function to add a file admin instance to the admin page. There are three parameters the file admin class will need. First is the path of the directory that we wish to expose. We will create this path in a platform-independent way by using os.path.join. For this example, we will expose our static folder. Next, the file admin needs the URI which the page will be available on. Finally, we need a name for our page to list in the navigation bar. That's all that is needed for now. Let's see the results of this code. In your browser, go to localhost/admin/ and you will see a new link on the top called Static Files. Click on that link and you will be taken to a new interface. On this page, you can upload new files, create new directories, and delete files. You can also go to each file and download anything you wish. Let's add some more features to our simple file interface. But first, we need to secure the page like the other views registered on the admin interface. In the admin.py file, we need to create a new class that inherits from FileAdmin called CustomFileView. This will have the same is_accessible method as CustomModelView. Now that the page is secure, we can move on to customizing it. The first thing that we should do is restrict the type of files that can be uploaded to the server for security reasons. This will partially prevent us from accidentally uploading a wrong file. By using a class variable called allowed_extensions and passing it a tuple of strings, we can whitelist certain file extensions. The ones listed here just allow text and image files. Next, the file interface allows you to make changes to text files on the server with the editable_extensions class variable. This class variable also takes a tuple of strings, and all of the values must be the names of extensions which represent plain text files. Let's go to the browser and see all of this in action. Now, if we reload the page and go to a text file, say one of our JavaScript files, we can click on it to bring up the editor interface. It's rather bare bones, but it will allow you to make live changes on the server without needing to use remote logins. Great! It works. Now you have a nice admin interface. You may wonder why it looks different from the rest of the site. This is because Flask Admin uses the older version of Bootstrap version 2, whereas we use a newer version, version 4. While it is not impossible to change the code to the newer Bootstrap version, it is pretty difficult to end. The interface that comes out of the box is nice enough for the admin interface. The visual difference in design isn't a big deal, since the regular users cannot see the admin interface anyway, and we as admins can deal with this distinction. Let's review what we have accomplished in this section. We downloaded and set up Flask Admin, a Flask extension which allows easily constructing admin interfaces. We created pages on our interface which allowed us to edit, create, and delete all of the models that we created. We also created a page which allows us to view, edit, and upload files as well as create new directories, all live on the server. We accomplished all of this in very few lines of code. In the next section, we are going to extend Flask's functionality even further by using more Flask extensions. Hello and welcome back. This is the first video in Section 8, Extending Our App. This video is titled Flask Debug Toolbar. In this section, we are going to cover 3 different Flask extensions that we will be adding to our app. We will also look at Flask Cache and Flask Assets. These extensions have a focus on speeding up our app while also providing some tools to help in development. In this video, we will cover the Flask extension Flask Debug Toolbar and how it can be used to aid development of our application. Flask Debug Toolbar is a simple Flask extension that adds a lot of debugging information directly into the web page. This sidesteps the need for a traditional debugger or a lot of print statements when trying to debug a part of your application. The first step is to install Flask Debug Toolbar with pip in the terminal. Just like all of the other Flask extensions we have used, we will need to initialize the extension in extensions.py. Then, we will import the extensions object into _init_.py and register it to the application object. And that's all that is necessary for Flask Debug Toolbar. If your configuration object is setting debug to true, then the toolbar will appear. If debug is false, then it will be hidden. Now let's go to the web browser to see the toolbar in action, as well as explore all of its different features. As you can see when I load the home page, the toolbar is automatically shown because we are using the debug configuration object, which sets debug to true. If you don't want to see it or you're not using it, you can just click on the Hide button at the top. Let's walk through its features. Clicking on the button that displays your current Flask version will display all of the versions of the Python packages you have installed with pip. This is useful if you have a bug in your code, which is caused by out-of-date software rather than your code. Next, clicking on the button with the label Time will give you a breakdown of how much time was spent on the CPU rendering the page. The next two buttons have to do with the HTTP request and response, and allow you to see exactly what the browser requested and how the server sent back its response. The next button, labeled Config, lists all of the Flask configuration variables, including config variables for the Flask extensions. The button labeled Templates shows all of the templates that were rendered for this page load, as well as the data that was passed to them. Next up is the SQLAlchemy button, which shows all of the queries that were passed to the database and how long they took. You can even press the Select and Explain buttons to get a list of all of the rows that the query returned and how the query was executed on the database. The Logging button is for capturing any calls made to a Python logging object in the view. We don't use any of the loggers in the logging module, so there is nothing here. The Route List button shows all of the routes in the application, which functions those routes are tied to, and which HTTP methods those functions accept. Finally, we have the Profiler, which is disabled by default, so click the check mark and reload the page. Clicking the Profiler button again shows a list of every function that was called when the page was loaded, how many times that function was called, how much time each call took, and what was the total time spent on all of the calls to that function. This is extremely helpful when trying to speed up your application, as your intuition of what is slowing down your app is a lot less accurate than the real information and can lead to a lot of wasted time. So to wrap up, we have installed a very useful extension that provides a lot of information when developing our application. It saves a lot of time when trying to debug, as well as help identify the bottlenecks in your code. In the next video, we will look at another Flask extension that will allow us to cache the results of functions in order to greatly speed up our app. This is video 2 of section 8, Flask Cache. In this video, we are going to introduce another Flask extension called Flask Cache and show how it can greatly speed up your app. Flask Cache is an extension that allows the results of Flask view functions and normal Python functions to be held in memory after they are executed once. When the function is called the next time, the function will not run again. Instead, the results of the previous run will be pulled from memory and returned. This can result in huge increases in the speed of your app. First, we need to install Flask Cache from the terminal with pip. As with Flask Debug Toolbar, we now need to initialize the cache object in the extensions.py file. Then, we will import it into the _init_.py file and register the cache object on the application object. Now let's cache the result of a view function. Using Flask Debug Toolbar, we can easily find a slow page that can benefit from caching. One of the slower pages in our site is the individual pages for movies, as they have a lot of database queries. For example, this page has 9 different queries and takes 17 milliseconds to render. Let's use Flask Cache to cache that page and see the difference caching can make. In the dev config object, add a line which sets the variable cache_type to the string symbol, which tells Flask Cache to save the results in memory. There are a lot of different ways to store the results of cached functions, but the simple option will work for most cases. Having this in the dev config is just for demonstration, because you don't want pages to be cached while you're actively developing them. Now, in the main.py file in the controllers folder, import the cache object and add the following decorator to the movie route. The timeout value is the number of seconds that the cached value will live before the app will grab the result again. The value you set this at will depend on how often you think the data on this page will change. As the movie data very rarely changes, we can set this to a high number. Now let's look at the page rendering time again after 2 page loads to have the results stored in memory. As you can see, the rendering time dropped from 50 milliseconds to 0.3 milliseconds. Great! In this video, we demonstrated how caching the results of your pages can greatly speed up the page load time. This will give your users a better experience and increase the chances of people staying on your page. In the next video, we will look at another Flask extension which will apply some filters to our static files in order to further speed up page load times. This is the third and final video of the 8 sections of this series, which is titled Flask Assets. In this video, we'll be looking at a new Flask extension called Flask Assets. Flask Assets will add another speed boost to our application by applying various filters to our JavaScript and CSS files. Here's how Flask Assets works. In your web browser, when you load a page, the first thing that is downloaded is the HTML code of the page. After the HTML is fully downloaded and parsed, the page will start downloading the JavaScript and CSS files. The web page will only fully render once all of the JavaScript and CSS files are downloaded. So now that we have already sped up the creation of our HTML, we can speed up the downloading of our static files with Flask Assets. We can achieve this because Flask Assets does 3 things. First, it concatenates the contents of multiple files into one file. This reduces the overhead of multiple HTTP requests, and many browsers can download many static files at once. Thus, reducing the number of files, even without reducing their size, means the browser can download more files at once. Secondly, Flask Assets can strip all white space and line returns from files, which can reduce the size of the concatenated files by up to 30%. Finally, Flask Assets modifies the HTTP response of our static files by telling the browser to store the static files locally. Every time the user now visits the page, the browser will just pull the static file from the logic storage rather than downloading it from the server. Flask Assets can also handle compiling your LESS and CSS files or your TypeScript and CoffeeScript files to CSS and JavaScript files respectively. Many of you might have used a program like Grunt or Gulp in order to solve this problem and might be asking, why don't I just use those instead? There are so many problems with those built systems. One is that Flask Assets automatically detects changes in your files and reapplies your filters with no interaction on your part, and configuring Gulp or Grunt for live reload is trickier. Secondly, if you used Grunt or Gulp, you would have to write JavaScript. As always, the first step in using a new extension is installing it with pip. We'll also install the CSS min package to handle compressing our CSS files. Flask Assets is able to handle compressing JavaScript files, so there is no need for an extra package. As with Flask Debug Toolbar and Flask Cache, we now need to initialize the assets environment object in the extensions.py file. Then we will import it into the _init_.py file and register the assets_environment object on the application object. Flask Assets calls the groups of files that it concatenates together bundles. So we will create a separate file to contain all of our bundles called assets.py. In assets.py, the first bundle we will create is a bundle for our JavaScript file. We have two of them that need to be compressed together, jQuery and bootstrap.js. We have to pass the file paths to the bundle object in order for Flask Assets to know where the files are located. After that, we have to specify the filters we want. In this case, we will be passing a single string, but you can also pass a list of strings. Then, the output keyword argument will specify where the resulting file will be held. Using the same steps, we also create a bundle for our CSS files. Next, the bundles need to be registered on the assets_environment object in the _init_.py file. This can be done with the register method on the object. Finally, we have to change the base.html file to use our new static files. Because the URLs for the new static files are dynamic, we use a Jinja control block from the Flask Assets to add in the link to the file. In the control block, the URL to the file is exposed via the asset_URL variable, and we have to repeat this step for the JavaScript bundle. Using Flask Assets on single Bootstrap CSS may seem a bit redundant, since we already have a minified version in our project. But using Flask Assets would help us to extend and maintain our app in the future when we may decide to add more CSS files. Now back to the browser. We can re-examine the network requests of our page. As you can see, there are now less requests. If we click on each of these requests and examine the headers, you can see that Flask Assets adding the HTTP headers to tell the browser to cache the file. You may wonder why we still see jQuery.js in the requests. And the reason is that Flask Debug Toolbar comes with its own version of jQuery. If you check the Network tab or the source code, you can see our bundle. One final note. While developing, it's not very useful to have your files compressed, as it makes debugging harder. You can disable Flask Assets in development by editing your dev config object to set the assets_debug variable to true. Let's also replace minified jQuery with the original file. I'm going to download it using a simple curl command, but if you want, you may use your browser and GUI. Now let's update our bundle. Let's just replace the minified version with the original version, so we have control whether to minify it or not using Flask Assets. Let's test our app again. Now with assets_debug variable set to true, we can see original files, so future debugging may be a bit easier. Great! That brings us to the end of this section. Let's wrap up what we have accomplished in this section. We've installed 3 different Flask extensions: Flask Debug Toolbar, Flask Cache, and Flask Assets. These 3 extensions have made our app faster, more responsive, and easier to develop and debug. In the next section, we will look at using a task queue called Celery to do tasks asynchronously. This is the start of Section 9, which is titled Asynchronous Programming with Celery. In this section, you'll be introduced to Celery. Specifically, we will show you what Celery does and how it can be used to improve your application. The first video in this section is titled Installing and Understanding Celery. In this video, we will go over how Celery works, and we will also install all of the software necessary for Celery. Then, we will write some code to begin integrating Celery into our project. So, what is Celery? Celery is a system designed to allow programmers to offload expensive operations out of their program's process and into another process. This is important for us. It will block the rest of the processing that needs to be done until the expensive operation is over. Celery is an asynchronous task queue written in Python. Celery runs tasks, which are user-defined functions, concurrently, meaning multiple at once, through the Python multiprocessing library. Celery receives messages that tell it to start a task from a message broker, which is usually a message queue. A message queue is a system specifically designed to send data between producer processes and consumer processes. Producer processes are any programs that create messages to be sent in the queue, and consumer processes are any programs that take the messages out of the queue. Messages are stored until a consumer receives the message, after which the message is deleted. Message queues provide real-time messaging without relying on polling, the process of continually checking the status of a process. When messages are sent from producers, consumers are listening on their connection to the message queue for new messages. The consumer is not constantly contacting this queue. This difference is like the difference between AJAX and WebSockets. AJAX requires constant contact with the server, while WebSockets are just a continuous stream. To understand this better, let's walk through an example. Say we have an expensive database operation, and we want to have the main Flask process do other things while the operation is going on. First, we would define a Celery task that performs our SQL call. Then, in the view function that required the operation, we call the task we defined. This creates a message and sends it to the message broker. The Celery process consumes the message and starts the called task. Remember that this does not affect Flask because they are running in different processes. When the task finishes, Celery then sends a message into the queue containing the status of the tasks and results of the tasks if it has returned a statement. To start setting up Celery, we need to install a piece of software and 2 Python libraries. First, we can install Celery from pip. We also will install a Flask helper library for Celery called Flask Celery Helper. We'll be using Redis as our message broker in this course, so let's specify in pip that we will be using Celery with Redis. Also, we are going to be using the 4th version of Celery, which has official support for Python 3.5, which we are using. Right now the default version is the 3rd, so I have to specify the exact version. However, if you are using Windows, install the 3rd version of Celery instead of the 4th, since the 4th version doesn't support Windows. The code we will write should work for both versions of Celery, since we are not going to use advanced features of Celery. Redis can be installed in many ways. Go to their website at redis.io. I recommend visiting the download page. If you are running Linux, you can use your package manager to install appropriate packages. For example, if you are running Ubuntu, type apt-get install Redis server, Redis tools. If you are running Windows, use this link and follow the instructions here on this GitHub page. If you are running OS X, I recommend using Homebrew to install Redis. Homebrew is a package manager for OS X and Mac OS, and it can help you install many different programs and libraries. Installing Redis with Homebrew is simple. Just type brew, install Redis. If you don't want to use a package manager, you can always build Redis from source. Then we have to create a function called make_celery, which will create a Celery application that is tied to an application context and takes a Flask application as its only argument. In this function, we first create a Celery application passing in the configuration values, which we will add later to our configuration objects. We then update the Celery configuration to hold all of the values that our Flask configuration holds. This allows us to configure Celery without having to create a separate configuration object. Next is the code that will mess with the Celery internals to get the application context working. Don't worry if you don't understand what is going on here. It's not important while using Celery. Finally, the function will return the Celery object. To end the file, we create an application instance with createApp and then pass the application to the make_celery function and save it to a variable named Celery, which the Celery process will use to try to run the application. Now, in the config.py file, we need to add two values, one to tell Celery where our messages to start tasks will go, and one to tell Celery where the results of tasks will go. These values are named Celery_broker_URL and Celery_backend_URL respectively. Both of these values will be the same, a SQLAlchemy style URL to read our Redis instance. Next, we have to create another Celery application object in the extensions.py file using Flask Celery helper. We also have to manually set the back end of the new Celery object like so. Finally, on the _init_.py file, we import the Celery object and register it on the application object in the create_app function. Okay, so far we have a solid understanding of what Celery is and how it can be used in our application. We also have all of the code we need to start creating tasks. So in the next video, we will start creating some tasks and start looking at some examples of practical applications of Celery. This is video 2 of section 9, titled Writing Tasks in Celery. In this video, we are going to start creating some tasks for Celery to execute in the background. We're also going to explore some alternative ways of calling tasks. In a new file called tasks.py in the WFDB directory, we're going to create a simple example task that just echoes what was given to understand how tasks are called and defined. Import the Celery object from the extensions file, and then we need to define the echo function. All this function will do is return a single parameter. Next, we need to make sure that our code is executed when the application is initialized, so in the _init_.py file. Before we use our new task, we need to open two more terminal windows. In the first one, we have to start the Redis server. Then, in the second window, we have to run the Celery server called the worker with the following command. This command will run the server with Celery_runner.py file and will also display debugging info so we can see what is happening. Oops, we have a missing import. Let's fix it real quick. Now we can test this task using our manage.py shell. First, import the echo task from the tasks.py file. If we call the task as it was a normal function, it acts just like a function and is executed in the same process. But if we use the delay method on this, then the function is run in the Celery worker. If we take a look at the Celery worker window, we can see the debug info showing that the task was called and the parameters that it was called with. Going back to the manage.py shell, if we save the results of the delayed call, we can see several things. 1. We can see the status of the task, whether it is done, if it is completed successfully or not, and we can call the get function. The get function pauses the current process until the task returns the result of the function. Or, if the task is already completed, it just returns the result. Remember, there is no need to call the get function if your task does not return anything, which is a common pattern. Let's explore some of the more advanced features of Celery, namely callbacks and countdowns. Before we do that, however, we need to understand the delay method more clearly. The delay method is shorthand for the following. The S method creates something called the task signature, which is what Celery uses to identify the task to be called and how to call it. You can execute just the S method to see what it returns. The apply_async function allows us to configure some things about our task call. For example, if we pass the countdown keyword argument to apply_async, we can tell Celery the number of seconds to wait before running the task in the Celery worker. If we instead use the ETA keyword and pass the datetime object, we can tell Celery the exact second that we want the task to run, no matter how far in the future. For the next example, we will need a simple function that takes two arguments and multiplies them. Now import the function and call it with the numbers 4 and 5. But in the apply_async function, we will add the link keyword, which takes a single or a list of task signatures to execute. The result of each task will be passed as the first parameter to the next signature in the chain. If we pass a signature of a multiply call with a 3, the final equation will be 4 by 5 by 3. So if we look in the window that is running the Celery worker, we can see the error. If we rerun it and we look in the window that is running the Celery worker, you can see the final result to be 60 as expected. But if you call the get function of the captured call, you will get 20 back as it only returns the results of the original call. Use this if you need to chain tasks together, but you don't need the final result. Congratulations! This brings us to the end of this video. Let's wrap up what we have learned in this video. We have learned how to define tasks in Celery and how to call them. We learned how to make Celery tasks execute exactly when we want them to, and we learned how to chain the results of tasks together. In the next video, we will explore periodic tasks in Celery. This is the third video in Section 9, titled Periodic Tasks in Celery. In the previous video, we saw how to write tasks in Celery. In this video, we'll learn how to use Celery to schedule tasks to run at specified intervals with a real-world example. The way Celery schedules periodic tasks is by creating a dictionary in your configuration that tells Celery what tasks to run, with what arguments, and when. For example, let's tell Celery that our echo task should be run every 5 seconds with hello world argument. In the config.py file, add a new variable called celerybeat_schedule, which will be a dictionary. Every entry in the dictionary will be another declaration for a periodic task. The key of the task can be whatever you want it to be, but this is the name that will show up in your logs, so choose something descriptive. There are 2 required fields of the tasks dictionary. One is task, which is the name for the task itself. The second is schedule, which for now will be a datetime time delta object. This is the simplest way to set up a schedule for your task. If we wanted the task to run every 5 seconds, we would define a time delta object that was 5 seconds long. If we wanted a task to run every 24 hours, 3 minutes and 40 seconds, you just have to define a time delta for that period. We will examine more precise control of the schedule in a moment. You also can define the positional arguments of the function with the args key and a tuple for the value, and the keyword arguments with the keywargs key and a dictionary as the value. Let's not forget to import the time delta object. Let's see this in action. Kill the Celery worker process and restart it, but this time with the B option to start the periodic tasks. If, however, you are ever running multiple Celery workers, you need to run the periodic tasks in a separate process with the following command. Now, if you watch the log of the Celery worker, you should see the echo command return the hello world parameter every 5 seconds. Some of you who are more familiar with your operating system of choice might ask, why don't we just run these tasks in the OS's task scheduler like cron? The answer is convenience. By using Celery, not only are we able to use the application context in our periodic tasks, but we also don't have to write a separate script for cron to call. Also, by keeping our periodic tasks in our project directory, we're able to update them without changing any system files, like cron scheduling file, to update our tasks. Updating them is just a simple deployment. Let's examine a more fine-grained way to control our task schedule. We're going to use the Celery Schedule's cronTab class, which we will initialize much like the timeDelta class. But instead of a period of time to wait, cronTab represents a specific time to run. For example, the cronTab class initialized with hour equals 0 and minute equals 30 will be executed every day at 12:30 a.m. because the cronTab class works on a 24-hour representation. Crontab can take 5 different parameters: minute, hour, day of week, day of month, and month of year, all of which take 3 different types of input. If we have a specific time in mind, we can just pass an integer like we just did. If we pass a string of comma-separated integers, the task will be run on all of those integers. For example, if we wanted to run a task every day at 3:30, 4:30, and 5:30 p.m., then we would initialize the crontab in the following way. The next string representation we can use is a way of defining a modulus operation. For those of you who don't know, a modulus operation is a way of getting the remainder on a division of 2 numbers. We can define a modulus division, and when the division equals 0, meaning it is perfectly divisible, then the task will run. For example, if we wanted a task to be run every 15 minutes on Sunday and Monday, we would initialize the crontab object like so. Let's build something practical for our application with this new knowledge. One great way to keep an online following is to create a mailing list. So let's build a weekly digest of all of the blog posts that we created in that week. First, we need a new task in our tasks.py file, and let's call it digest. The first thing we need to do is find the dates that this week started and ended on, which is unfortunately harder than it sounds with Python's standard library. This code creates 2 variables called start and end that contain datetime objects for the start and end dates of the week. How this code works isn't really important. It is just a workaround for the inadequate calendar functionality in Python. Next, we use all of those dates to query for all of the post objects made in between those 2 dates. Then, we check if there are any posts that we have written, because it would be bad to send out an empty email announcing that no one wrote a post for your blog that week. Then we use Python's smtplib and MIME-text representation to render out a template with our email's HTML and send it to a list of hard-coded addresses. I'm going to use my email addresses for testing purposes. As you can see, the digest.html file is really bare bones, as this is just an example. Let's also make sure we have all the necessary imports in tasks.py. The last thing we need to do to make our task run is to make the declaration in the Celery beat _ schedule. We have to make sure that we send the emails at the end of this week for this code to work correctly, so let's run the task on Sundays at 11:30 p.m. Let's use a test blog post using admin interface. And let's say we posted it on Friday by author. Let's save it. And now you can see it here. Sending emails requires a running SMTP server. I'm going to launch an SMTP server that comes with OS X postfix using default settings. Keep in mind that if you are running a different OS, you may need to install and configure an SMTP server. I'm not going to cover configuration here, since this isn't a system administration course. And sending emails is complicated in today's world and probably deserves a course of its own. Oops, it looks like we have an extra argument in digest function. Let's fix it real quick. Okay, let's make sure the server is running. Speaking about difficulty in properly configuring an email server, I failed to deliver an email to my @gmail.com address. But sending an email message to @yandex.ru worked okay. But the email message got delivered to my spam folder. I can check the logs to see what went wrong with the gmail.com address, and we can see that we haven't configured our email sending software properly. For testing purposes, you can simply print the debug information or check your SMTP mail server log like me. In production, it is a good idea to let other people handle email delivery for you. You can use services like Mailgun, MailChimp, or SendGrid. So let's wrap up what we have accomplished in this section. We've been introduced to Celery, a program that allows us to write functions that run in parallel to our application and do not pause execution of the server. We saw how we could write tasks for Celery and how we could call tasks and integrate them into our application. We also learned that we can have tasks executed on a very specific periodic schedule. In the next section, we are going to examine how to ensure our application's code is correct through automated testing. Hello everyone and welcome to another video in the Mastering Flask video course. In the previous section, we worked with Celery to program asynchronously. This is the start of section 10, which is titled Testing Our App. In this section, we will look at what unit testing is and why it will be beneficial to your app. We will cover the basics of unit testing, then we will go over the various specialized methods of testing the different parts of our app. We will also explain the concept of code coverage at the end of this section. This video is titled, What is Unit Testing? In this video, we will answer the question, What is unit testing? We will also go through a hypothetical unit test, as well as write the first simple tests of our application. So, what does it mean to test software? Testing software is very simple. All it involves is running particular pieces of your program, like a simple method, a few classes or a whole module, and saying what you expect the results of that piece to be, and comparing it to what the results from the piece of the program actually are. If the results are the same, the test passes. If the results are different, the test fails. This simple mechanism verifies that your code is functioning properly without any human error or misconceptions. Typically, these tests are run before the code is deployed to the line server in order to make sure broken code is never seen by your users. But in relation to software testing, what are unit tests? In testing, there are three main types of tests. Unit tests are tests that verify the correctness of individual pieces of code, such as functions. Integration testing, which tests the correctness of various units of programs working in tandem. And the last type of testing is system testing, which tests the correctness of the whole system at once, rather than individual pieces. We will be focusing on unit tests for this section, as integration and system tests rely heavily on your personal production environment and not on Flask. Let's go through a hypothetical example. If you had a function that calculated the average elements of a list, you would test if the function was functioning properly by giving it the list 1, 2, 3, and test if it gave back 2. Validity in Python is tested with the assert keyword. What assert does is run a Boolean test, and if it returns true, it does nothing. But if it returns false, it throws an error. Here are some examples of assert statements to test if our function is working correctly. Given a list of 1, 2, and 3, we expect 2. Given a list of 0, 50, and 100, we expect 50. And that's really all there is to it. All unit testing is, given some set of inputs, what do you expect the output to be? Now that we understand the mechanics of unit testing, we can start adding unit tests into our application. The first step is to create a new folder called Tests in the root of your project directory. The first test that we will write before getting into more advanced tests is if our application's createApp correctly initializes our app object with the correct configuration values. To do this, we will use the unit test library in Python's standard library, which will take care of running all of our tests as well as providing some helper functions. First, create two new files in the test directory called testconfig and init.py. In the init.py file, import the createApp function and create an app from devconfig. In the test_config.py, import the created app object. Tests are created with the unit test library by creating a class in the file that inherits from the unit test test case. This class name must also be prepended with the word test. Each test will be a method of this class and is differentiated from the other methods of the class by also prepending them with the word test. There's also the set up and tear down methods. Which are called by the unit test library before and after every test respectively. We'll use these later in this section. So now we can start writing our first test. Create a class called testConfig that inherits from unit test test case. Next, we will need a method called testConfigLoading, which will test if the createApp function correctly loaded our devconfig object. This method will have two asserts, one to test the debug option and one to test the SQLAlchemy database URI. Now we can run the test we have written. Go to the root of your code and run Python m unit test. This command uses the unit test library to automatically find any tests that you have written and runs them. As you can see from the output, I found one test and it completed successfully. Great! We are now at the end of this video. So far, we have learned what unit testing is, how to do it in Python, and we have written our first test for our application. In the next video, we'll start writing tests for our SQLAlchemy models. Hello and welcome back. In the previous video, we learned what is unit testing. This is video 2 of section 10, titled Testing Our Models. In this video, we are going to cover how to test the unit test library to make sure our SQLAlchemy models are functioning properly. The first step we are going to take is to create a specialized test configuration object. This will allow us to test our SQLAlchemy code without disturbing our development database. It is going to look almost like the devconfig object without some of these unnecessary values, and we will also change the SQLAlchemy database URI value to SQLite. The new SQLAlchemy URI creates a new SQLite and is destroyed when the test runner ends. Also, change the app in _init_.py to use the newly created testConfig object. We will need the setup method that I mentioned in the previous video. Each of the tests in this test case will need the DB object also. Because we are working outside the Flask application context, we will have to manually modify our DB object to correctly link with our application object. Finally, we need to create all of our tables in the new database with the create_all method. Next, we'll need to define the teardown method to make sure that the modifications from one test do not interfere with another test. In the teardown method, we will call db.session.remove to clean up the session, and db.drop_all to drop all of the tables. The first type of test that covers models is testing if they initialize correctly and can be saved to the database. Using the user model as an example, and then queries the database to make sure that the user is correctly saved. The second type of test we will write for our models is testing the methods on the models. If your models have utility methods on them, like our user objects method for setting and checking passwords, then it's best that we test those as well. In a new test method called test_user_password, we will create a user object, set its password, and then use the check_password function to see if it was correctly saved. The third type of test that we will cover in this video are tests that check relationships between models. In a new test method called test_role_relationship, we will test the relationship between the user model and the role model. First, create both a user and a role object with the role object saved to the user object and commit them to the database. Then, query for the first user object with the role that we saved, and check if it represents the same row in the database as the original user object we saved. Here we could have created one big test instead of 3 smaller ones. However, it is a good practice to make smaller tests separated from each other. Okay, let's test our app. And we have an error here. This is because we've updated the config, but not the test that tests config loading. Let's fix it real quick. They work. Excellent! We have created 3 different types of tests in which to verify that our model code is functioning properly. If you apply these 3 types of model tests to all of your models, then you can be sure that every piece of your SQLAlchemy code is working. In the next video, we will cover methods to test if your view functions are working properly. In the previous video, we saw how to test our models. This is video 3 of section 10, titled Testing URLs. In this video, we will cover some specific methods to test Flask view functions, as the tools we have seen so far are not adequate. But we will not be testing the behavior of each page in the browser, since it is only remotely related to Flask. In a new file called test_urls.py, we will need another test case class called testURLs. We will also need the set up and tear down methods from the test models class in the previous video, with one small addition. In order to test the functionality of our view functions without having to run the test server, we will use a little-known feature of Flask, the test_client object. The test_client allows us to make simulated HTTP requests to our view functions and get the response objects back. To make the test_client available to each of the test methods, save it to the instance variable client. Like in the previous video, this video will not create every test that should be created for your view functions. Rather, this video will cover some different types of the basic tests that can be created to test your view functions, which will give you the tools to cover all of your functions. The first basic test that we will create is a test to make sure a page is returning successfully. In a new test method called testHome, we will use the get method of the test client in order to simulate a get HTTP request to the /URI and save the result. The test client provides methods for all of the standard HTTP methods as lowercase versions of the method names. The result variable is just a Flask response object, so we can easily tell if the function completed successfully if the HTTP code is equal to 200. If you want to check the content of the page, for example, to test form submissions, then you can examine the contents of the returned page using the getData method of the response object. Another test that we can perform is to test if restricted pages keep out logged out users. Building off of the last test, all we need to change is the URL to one of our Flask admin pages and status, instead of code 200 to 403. As you might know, HTTP has many different status codes. You can find the list of them at this Wikipedia page. We can also test if our login mechanism works with the test client. In a new test method called testLogin, we first need to create a new user object to log in with. After the user is saved to the database, we can use the post method of the client to send a post request. If we post to the login page with our new user's username and password, and if we tell the function to follow any redirects, we can test if the phrase logged in successfully is present in the resulting page. Now that we have a mechanism to log in, we can also test if pages that require logins correctly let a user in once they are logged in. Using the testLogin method as a base, we will need a new test method called testAdmin logged in. In addition to creating a new user, we need to add an admin role to the user to allow it to access the admin pages. Also, we need to add a get call to the user admin page and change the assert to check if the status is 200. Let's run our tests. Excellent. They work. Great. In this video, we explored a little-known feature of Flask and used it to test the functionality of our view functions. you now have everything you need to write tests for all of the features of your web application. In the next video, we will cover the concept of code coverage and how it can be used to make sure your tests are of good quality. In the previous video, we tested URLs. This is video 4 of section 10, Testing Code Coverage. In this video, we will discuss the concept of test coverage, and we will cover how to get it for your tests. So, what code coverage is the percentage of your code that is executed during your tests. That's it. This simple statistic is extremely powerful, as it gives a definite measure of the quality of your tests. If your tests are only covering 50% of your code base, then your tests need some serious improvement. Typically, you want to aim at 95% coverage, as there is always going to be code that isn't feasibly testable. To get the coverage of our code, we need to install the coverage package from pip. Next, we need coverage to run our tests, which we can do by running the command coverage run source wfdb m unit test discover. This command simply tells coverage to run our previous test running command and only measure the coverage of the files in the wfdb directory. After your tests run, a new file called coverage will be made in the directory of your project. We can get some basic statistics from this by running the coverage report. As you can see, the tests are only covering 63% of our code. But this is a rather simplistic method of looking at your coverage, as you can't tell explicitly what parts of your code are missing. Thankfully, we have the coverage HTML command, which creates a report of all of our code in a browse-able manner. After you run the command, you should see a new folder called HTML_cov in your project directory. If you open the index.html file in your web browser, you can start browsing a specialized view of what code is and isn't executed in your project. As you can tell from this report, I never made any tests for the Movie API, or any API for that matter. And now that I have this information, I know exactly which tests to improve, or what new tests to write. Let's wrap up what we covered in this section. We learned what a unit test is and how we could do it in Python. We also learned specific methods of how to unit test our SQLAlchemy models and view functions. And finally, we learned what code coverage is and how to use it to write better tests. In the next section, we will look at different strategies for deploying our application to production. Hello everyone and welcome to another video. In the previous section, we learned how to test our app. This is the start of section 11, which is titled Deploying Our App. In this section, we will look at different ways of deploying our app. We will cover 3 different ways: simple VPS, Elastic Beanstalk on Amazon Web Services, and Heroku. This video is titled Preparing Dependencies for Deploying. In this video, we will take a look at managing dependencies. We will also upgrade dependencies and go through our app to make sure it doesn't use duplicate code. Let's talk about managing dependencies. While developing our app, we installed a lot of external libraries using pip. We used Virtualenv to keep Python packages in an isolated place for our app. However, using our own personal hardware, like a laptop, is the best idea. We're going to use a deployment platform from vendors like Heroku, Amazon, DigitalOcean for this. How do we ensure the production environment is the same as development environment? We could simply copy the Virtualenv folder. But it doesn't always work, so you shouldn't rely on this. For example, I can't take my OS X virtual envelope and use it on Linux. The best way is to simply list all the packages with versions in a text file, and then install the exact same versions using pip. We can use pip freeze to list all installed packages in our virtual envelope folder. Let's save the output to requirements.txt, which is a customary name for files with dependencies. Now, for testing purposes, I'm going to deactivate the virtual environment and remove the wfdb envelope directory, and then recreate the environment. Now, when I run the tests in the fresh virtual envelope, You can see them fail since the packages aren't installed. If you install the dependencies by typing pip install -rrequirements.txt and run the tests again, they will work. We have successfully recreated our previous virtual environment. What if I need to update versions? I've been working on mastering Flask for a while and haven't upgraded my virtual envelope. It can be a good idea to upgrade package versions every once in a while. So let's see what packages have new versions with this command. Pip list --outdated --format equals columns. OK, we can see that Flask, Flask WTF, Flask Login, Flask WTF, SQLAlchemy, Celery and IPython have newer versions as well as their dependencies. We also had this. Let's update them. Oops, I need to provide --, upgrade flag. Let's run our tests. They work, but we have a bunch of warnings here. Let's fix them. First, we have to replace all imports like flask.ext.login with Flask Login. This is simple, although a bit tedious, since we have to do it for every extension imported in every file. It also seems that Flask cache isn't actively maintained. Let's replace Flask cache with Flask caching, which is a fork of Flask cache. Next, we have to do a couple of renames for Flask WTF. As you can see, we have almost no warnings, except for disabled cache, which is intended, and importing flask.ext.SQLAlchemy warning, which I checked. It arises from Flask Debug Toolbar code. The Flask Debug Toolbar code was updated in master branch on GitHub, but it looks like there is no fresh release that we can install with pip. We will need the requirements.txt file in the upcoming sections, so let's upgrade it. Great! We're all ready to start deploying our app. So far, we have learned how to use pip to reactivate virtual environments and upgrade package. We've also upgraded our app dependencies and fixed warnings. In the next video, we will deploy our app on a simple virtual private server or VPS. In the previous video, we added final touches to our app to make the deployment process smoother. This is video 2 of section 11. Using a simple VPS. In this video, we will discuss what a VPS is and learn how to deploy our app on a VPS. Let's say I have a laptop with our app running. Why can't I run my app on my laptop? Well, technically I can, assuming it is accessible from the outside. However, it is not convenient since my app will go offline when the power or network connection is down. I would also need to make sure that other software doesn't interfere with my applications running. Also, your home computer isn't necessarily accessible from outside because of network address translation. Okay, but what about running it on a commercial hardware at some company's data center? I could definitely rent a real machine, and many companies offer this type of service. However, modern computers are quite powerful, and many smaller apps don't need that much memory and CPU power. Given that the price for hardware starts from tens of dollars per month, it is somewhat expensive for smaller apps. Fortunately, many companies allow you to rent a VPS. VPS stands for Virtual Private Server. VPS, which is essentially a virtual machine, it has its own operating system, and you have a super user access to it. It is also configured to have networking and has its own IP address. And for many purposes, having VPS is equivalent to having a physical server. Each physical machine usually runs several VPSs, and each VPS gets a share of resources, memory, CPU, and disk. This means that VPSs are usually cheaper to run than physical servers. We're going to use DigitalOcean.com because they provide inexpensive on-demand VPSs. DigitalOcean has a nice UI that makes creating VPSs a breeze. Let's create a VPS. DigitalOcean uses the term droplet for a VPS, so click on Create a Droplet. You can choose from multiple operating systems and multiple locations for your VPS. I'm going to use Ubuntu on the smallest and cheapest VPS, and let's say my droplet is going to be located in London. Click on Create in the UI and wait for a few seconds. DigitalOcean emails a password, and we can use it to access our server. Let's take this IP address and the password from email message and use SSH to access our freshly created VPS. If you are running Windows, you have to use PuTTY as your SSH client. But on Mac and Linux, you can simply type SSH root at your IP address. Now we need to change the password. And finally, we have access to our server. We can now start working on actually deploying our app. Let's start by creating a new user, WFDB user, because it's a bad idea to run the code with super user privileges. Run add user WFDB user. The next step is to copy our app to the server. The best idea to transfer code from development machine to production is to use some version control system like Git. But for simplicity, I'm going to use SCP for remote copying. I'm also going to remove the virtual environment directory since we have to recreate it anyway. Let's connect again, and let's check if our app is here. Let's start by installing these packages with apt-get. Python 3-pip, Virtualenv, Nginx, Redis Server, and Redis Tools. Then, let's change our user to WFDB user. Go to Home Directory and then to WFDB directory, and then let's create a virtual environment and install Python packages. One thing I need to do is remove GNU readline from requirements.txt. Since this package is required on OS X, but not Linux. Then, run our familiar pip install -r requirements.txt. We can already launch our app using manage.py script. To make it accessible from the outside world, we need to provide --host_o.o.o.o option to the script. We can now simply run a web server using our familiar manage.py script. Let's test it. It works. However, our app is still running in the debug mode, and if we disconnect from the server, our app will stop running. We need a way to make sure our app is always running, and we need a way to start our app automatically if the server gets rebooted. Additionally, Flask's built-in web server isn't good for production use, so we need to use a suitable web server. DigitalOcean has great tutorials for deploying our app. I recommend checking them out. I'm going to do pretty much what I described in this tutorial. How to serve Flask applications with Gunicorn and Nginx on Ubuntu 16.04. Gunicorn will run our Python code, and Nginx will proxy requests for gunicorn since running gunicorn alone isn't secure because gunicorn alone is susceptible to denial of service attacks, example, SQLAlchemy. Let's start by installing gunicorn with pip. Then, we need to tell gunicorn where to get our app. To do this, create a new file called application.py. In this file, import create_app and create_app using prod config. I also forgot to add celery variables to prod config. Let's fix this real quick. Run gunicorn using this command. We can see that our app is running. Now we need to create systemd units. Systemd is an init system that is used by Ubuntu 16.04. We're going to create 2 unit files to tell systemd how to run our web service and Celery processes. There is a good guide on DigitalOcean for creating unit files. Create a file in etc. systemd system named wfdb.service. Systemd unit files consist of several sections. The first section is unit, where we add description and dependencies. We need network, and we need redis for Celery. The service section describes how to run our app. We provide a user account to run our app under. Then we provide environment variable path, which we set to bin directory inside our virtual environment. Then we provide the actual command to run our app. And finally, we tell systemd to run our app when our VPS is up and running. Then we need to create a second unit file, wfdb-celery.service. It is going to look pretty much the same. As you can see, the main difference is exec start command. Then, run the following commands to start our services. System control start wfdb. System control start wfdb Celery. Then let's tell systemd to run the services at boot time. System control enable wfdb. System control enable wfdb Celery. Finally, let's create nginx config. Create a new file named wfdb in etc. nginx sites available with the following content. Make sure that the server name is the IP address of the VSP, or its domain name if you have one. To enable this site, create a symbolic link in the Sites Enabled directory. Then, tell systemd to restart nginx. Now, if we go in browser to our VPS, we can see our app running in production. Okay, we learned a lot in this video. First, we learned about VPSs. Then we created a VPS on DigitalOcean and configured it to run our app all the time. In the next video, we are going to take a look at different methods of deploying our app, Amazon Web Services. Hello everyone and welcome to another video using Amazon Web Services. In this video, we will go over how to deploy your code to AWS and the modifications we need to make for that to work. We will also discuss what is PaaS. What is PaaS?
PaaS stands for Platform as a Service,
which is essentially a service platform available to developer where they can deploy their application. But the resource, for example, hardware, power, network, is maintained by the vendor company. At the cost of the freedom to completely control your technology stack, you gain assurances that your website will automatically scale with the number of users your site has, with no extra work on your part. Using PaaS also tends to be more expensive than running your own servers. So briefly, what is Amazon Web Services? AWS is a set of PaaS maintained by Amazon. AWS includes everything from web servers to message queues, to databases, to task schedulers. One of the most basic components is EC2, which is a service pretty similar to DigitalOcean. Using a nice UI, you can allocate EC2 instances, which are pretty much VPSs, just like DigitalOcean droplets. The component of AWS that we will be using is called Elastic Beanstalk, which is their web server PaaS. Elastic Beanstalk is a platform for web applications that offer many powerful features, so web developers do not have to worry about maintaining servers. For
Elastic
example,
Beanstalk is a
your
platform
Elastic
for web
Beanstalk
applications
application
that
will
offer many
automatically
powerful
scale up
features,
or down,
so web
depending
developers
on the
don't
number of
have to
users
worry about
visiting your
maintaining
service.
servers.
For Python apps,
For Python
Elastic
apps,
Beanstalk uses
Elastic
Apache
Beanstalk
in
uses
combination
Apache
with
in
a component
combination with
called
a component called
mod_WSGI
mod_WSGI.
to connect to WSGI applications,
So
there is very little extra configuration needed.
The
The Python version of Elastic Beanstalk is a bit old, 3.4, whereas we will be using Python 3.5 throughout the course. But we haven't used Python 3.5 specific features, so we can safely use Python 3.4.
specific features.
Installation on AWS is extremely simple. To get started,
you will
of course need an AWS account. After that is finished,
After you
grab
create
your
an account,
security
grab
keys from the
your
security credentials
keys from
page in the
security
AWS dashboard, as we will need them in a second.
Once you
Once you
have
have
your
your key
key
pair,
pair, do not
do not
share
share it with anyone, as it will give anyone who has access to it complete control over your platform instances on AWS.
If your case
You can
compromised,
install
you
AWS
can
command
always
line tools,
delete
so you
it
can deploy your app to
by
your new
clicking on
Beanstalk
delete link.
application.
Now we need to install the AWS command line. Pip install AWS EB_CLI. We need to tell the command line tools that our project directory is the code for our application. So run the following
We can
command.
install by using pip.
init. Now we need to install the
AWS
command. Pip
EBCLI.
install AWS EB_CLI.
We need to tell the command line tools that our project directory is the code for our application. So run the following command,
ebinit. This
command will ask for your login, as well as which of your AWS apps this code is for.
And other information.
The only file that we need is a file called application.py in the root of our project directory. We have already created this file in the previous video. AWS looks for this file, and a WSGI compatible object in the file called application to run.
In this file,
let's change app to application.
Now that we have everything we need, all you need to do to deploy your application
to Elastic Beanstalk is run ebinit and then ebcreate wfdb-eb. This may take a while.
The environment is successfully launched. Now go to
configuration.
And change the static directory.
And change the static directory to wfdb/static/.
This is necessary
to make static files accessible.
Now, if we click
Now,
on
if we
this link,
click on
we
this
go
link,
to our app.
we'll go to our
It
app.
works, but we need to make sure autoscale works correctly. Right now, we are running one server. But if we use ebscale2 command to bring up two servers, we will have two servers, and each one of them will have its own instance of SQLite database. When we make changes to our DB, for example, using Flask Admin, the changes propagate to only one of the databases. So we need a way to use the same database.
If we now
across
run
all
ebopen,
instances.
it will open a link to our app.
We
Now
can't
we need
do
to make
this
sure
with
autoscale works
SQLite, so
correctly.
we are going to use a different
Right now we
database
are
called
running one
Postgres.
server.
Postgres is a
But
free
if we use
software, and you can run
ebscale2
it
command to
on
bring up
any
two
machine,
versions,
including
we will
your
have two
laptop
servers,
or your
and each
VPS.
one will have its own instance of SQLite database. When we make changes to our DB, for example using Flask
Amazon
Admin,
provides a
the
service
changes
that
propagate
makes
to only one of the
provisioning
databases. So we need a
relational
way to
databases
use the
easy.
same database
It
across
is
all
called
instances.
Relational Database Service, or RDS. Go to Configuration.
Go to Configuration.
Then go to
Data Tier.
Data Tier.
Here we need to provide the database
and
credentials. Then click
create
Apply.
a Postgres instance. Let's choose the micro instance. Then click Apply. Creating a new RDS instance may take a while.
Creating a new RDS instance may take a while.
After we have created an instance, let's make our code work with the new database. Open config.py in your editor. Take your username, password, and endpoint, and combine them in an URL like this. WFDB is going to be the name of our database.
WFDB is going to be the name of our database. To make SQLAlchemy work with Postgres,
To make SQLAlchemy
we need to
work
install
with
an additional
Postgres,
package,
we need to
Psycho
install
page 2.
additional package, psycho.pg. Let's add it to
requirements.txt.
It is necessary to
It
have
is necessary
Postgres
to have Postgres to successfully install Psycho
We
page
need
2. We need to tell Elastic Beanstalk to install Postgres. Create a .eb extensions folder in the root of our project.
Create .eb extensions folder. In the root of our project. Then create file
Then create
packages
file packages.config
with the
with the following
prompt.
content.
Now our app is ready to use the newly created database. However, the database is still empty. We need to populate it with data. Migration process
Isn't always straightforward and can be very tricky, although there are tools that can sometimes help us. For example, PG Loader.
To make things
simple, we're going to use the dump I prepared. It will be available on the course GitHub page. Make sure you have Postgres installed.
We will need
CreateDB and P-SQL
programs. To import data from SQLAlchemy,
first create the database WFDB with CreateDB. Oops, my run failed.
To fix this,
I need to go to Services, VPC Security Group, and then I have to find the RDS Security Group.
VPC, Security Groups, then I had to find RDS Security Group, and then set inbound rules.
To allow outside connections by setting source option to
0.0.0.0/0. Now I should be able to access my database from outside.
Now I should be able to access my database from outside.
Next, we can run this simple
P-SQL command.
There are the following options.
We have the following options. Database name, host name, port username, and dump file.
User and dump file.
Okay, now we have our new database populated.
Let's check our app's config one more time.
Let's check our app's config one more time. The correct DB URL is here. But the debug option is
option
set to true for some reason. Let's fix this.
Let's
Now
update
let's
our
update
app on AWS
by running eb deploy.
Great. We have put our app in production. It works.
It works.
Well, it is
What
tricky.
about celery?
The first thing we could do is simply spin up an EC2 instance.
We could also spin up
EC2
EC2 instance, run celery on it, and use Redis provisioned Amazon Elastic Cache. It is also possible to run celery inside Elastic Beanstalk instance, but it is somewhat tricky.
It is also possible to run celery inside the Elastic Beanstalk instance,
stackoverflow.com/questions/14761468/ how do you run a worker with AWS Elastic Beanstalk? Then there is an option to run celery in a Docker container using Amazon EC2 Container Service. Finally, we could use Elastic Beanstalk's worker tier together with SQS for background task processing instead of celery. As you can see, there are quite a few different options with different pros and cons.
Okay, in this video we learned about AWS
and how to deploy web apps with AWS's Elastic Beanstalk. I also briefly outlined how to do background processing on AWS.
Don't worry if you don't
understand how to do background processing on AWS.
If you want something simpler,
stay tuned for the next video where we are going to cover deployment of Heroku. Hello everyone and welcome back using Heroku. In this video we will cover what is Heroku and how to deploy your app to Heroku. Heroku is another platform as a service PaaS provides that this video will cover. Heroku is a PaaS that aims to be easy to use for web developers by hooking into already existing tools and not requiring any large changes in the app. Before we begin, you will need a Heroku account to follow along. If you just wish to experiment, there is a free plan. Before we deploy our code, we need to make some modifications to our project to provide the files and configurations that Heroku needs. The first step in getting our app on Heroku is to create a file called procfile, which Heroku uses to determine how to run your app. In procfile, we only need 2 lines, one for web app and one for celery. We are already familiar with those commands from previous videos. Make sure the name of the WSGI object in application.py matches the provided name here. Then we need a small file called runtime.txt, which tells Heroku which version of the Python interpreter we're using. Next, create a new application. Next, we need to provision Postgres database and Redis. Heroku UI makes this really simple. Click on Resources. Let's add Heroku Redis. And let's add Heroku Postgres. There are other add-ons you can add to your application. To install it, use this command. Then run Heroku. You can see the full list of different plugins here. After we've provisioned Redis and Postgres plugins, we can see URL on the Settings page. The next step is to install Heroku's command line tools, as this is the simplest way to directly deploy your code to their servers. There are other options, like using Dropbox together with Heroku Web UI, but the command line tools allow you to have an easier control on your app. They can be downloaded from the URL on the screen. To test and debug your app locally, you'll also need to get config variables from Heroku. While we could copy and paste those variables, it is much better to use Heroku Config plugin. To install it, use this command. Then run Heroku Config, pull -awfdb. We can see our variables in .env file. Next, populate the Postgres database using the prepared dump wfdb.sql using Heroku pg:/psql command. You can ignore "these roles don't exist" errors. Finally, we need to update our create_app function to get settings from environment variables set by Heroku. Then call the function after from_object call. After you have downloaded the tools and made adjustments to the code, variables that we set from file. Run the following command, then call the function to log into your Heroku account and save your credentials. Then, in config.py, remove variables that we set from file. And make sure it uses cache_type simple. Then change celery_runner.py to use prod config. Then make sure you have Psycho-Page 2 and Gunicorn installed. And update your requirements.txt if necessary. Before you deploy to Heroku, The command form and start will simulate the Heroku server so you can test if your app runs before you deploy. The way that you deploy with Heroku is by pushing to a new remote Git branch. Heroku will automatically detect that you have pushed new code, and it will restart your server. To create this remote branch, run the following command. I don't get a Git repository at this directory, so I'm going to create one. But you may use an existing Git repository. In fact, it is a great approach to start using Git from the very beginning of development. To create this remote branch, run the following command. Use this git command to push to the Heroku branch. If everything went well, you will now have our app running on Heroku, which can be seen by running Heroku open. And we even have a nice domain name here. That's all for Heroku. So let's review what we've covered. We modified our code slightly and installed some new tools and got our code running on the servers. Let's wrap up things in the last video of this course. Join me. Hello everyone and welcome back. I hope you enjoyed the video series. In this video, I would like to outline what improvements can be made to our WFDB app so you can test your acquired skills. One of the improvements would be using Flask Migrate for database migrations. For example, adding or removing tables or columns. While we could use raw SQL queries, this isn't the best option. It is much better to use a dedicated Flask extension that makes managing migrations much easier because it will automatically detect changes in your SQLAlchemy models. It also has nice integration with Flask script. One of the changes we could make is adding email column to our user. Another related improvement we could make is allowing logging in by providing emails as well as changing our registration form to include email field. Then you could change our digest sending code to send the digest to every user. A good Flask extension that you could use is Flask User. It makes things like emails, password resets, and password changes easier. Sending emails from your server is difficult because you have to properly configure your server, so other servers would accept your emails and not mark them as spam. it is much easier to use a service like Mailgun, MailChimp, or SendGrid. There are free plans which are great for smaller apps. Perhaps you could update our digest sending code to use one of these services. And if you are using Heroku, these services are available as plugins. I haven't used version control systems much throughout the course because this isn't the course on VCS. However, using VCS is really good practice, so I encourage you to use it. For example, Git. If you aren't familiar with Git, there are a lot of resources available. This is, of course, free official documentation. And Pact Publishing has a lot of courses on Git to offer. If you are planning on using only Heroku, a recommended pattern is putting all of your settings to environment variables. So you can move all settings, like debug equals false or secret_key to the settings. If you plan to use Heroku exclusively, it would be a good idea to get rid of your configuration objects entirely. As a reminder, you can synchronize your .env local file for Foreman and remote Heroku settings by using Heroku Toolbelt. The file uploading part will not work properly on AWS Elastic Beanstalk or Heroku. It may seem to work, but it will stop working properly when our app is scaled to multiple instances or when our app is moved to another machine. Since we have no way to control when this happens, it is better to disable file uploading altogether. We have created models and tables for tags. Our tags aren't clickable. It's a good idea to add filtering by tags. While having simple cache options may be enough for some cases, it is often better to use Redis. Flask caching allows us to use Redis as backend for caching, and it is actually pretty simple. That's all for this video and the course. I hope you have enjoyed the course as much as I have putting it together for you. Keep learning.